morning and a very warm welcome to our Honorable Vice Chancellor, Professor Singh Lather, Registrar Dr. Nitin Malik, our distinguished guests, Professor Shantanu Chaudhary and Professor Babatosh Chanda, our illustrious panelists for the post-lunch session who have joined us for the inaugural, Professor Indu and Professor Dwipaboti Brahma, guests from other universities, Dean Planning, Professor Kartik Dave, esteemed colleagues, members of staff, research scholars, and team from the press for the first awareness workshop on harnessing artificial intelligence for social sciences and humanities. Today, we at Dr. Ambedkar University are laying our first step on a new stepping stone that explores the possibilities of alliance between social sciences, humanities, and artificial intelligence that represents a convergence of technology and study of human culture, art, and society. It was in the mid-1950s that McCarthy coined the term artificial intelligence, which he would define as the science and engineering of making intelligent machines. Over the years, the field of artificial intelligence has rapidly advanced and has the potential to revolutionize various domains, including social sciences. This workshop aims to bring together experts, scholars, and students to explore applications, challenges, and opportunities of artificial intelligence in social sciences. Artificial intelligence is now being used in an ever-growing range of human activities. In the present era, virtually every domain benefits from intelligent solutions offered by approaches, methods, and techniques of AI. Given the increasing and pervasive integration of artificial intelligence across all facets of contemporary existence, it is imperative to deliberate on its integration with and implications within the realm of social sciences. With this background, we may begin. And to begin with, may I invite our Honorable Vice Chancellor, Professor Singh Lather, along with our dignitaries and Professor Nitin Malik, Dr. Kartik Dave, to please light the lamp and initiate the events for the day. I request the student volunteers to please assist. Thank you, ma'am. Thank you, sir. Thank you. I request Professor Singh Lather, Honorable Vice Chancellor, along with Professor Babatosh Chanda and Professor Shantanu Chaudhary, along with Dr. Nitin Malik, to please come on the dais. May I request Dean Planning Division, Professor Kartik Dave, to welcome our Honorable Vice Chancellor and distinguished guests on stage with potted plants. Thank you, ma'am. Thank you, sir. Time and again, it has been reiterated by our Honorable Vice Chancellor that the integration of technology and social sciences and humanities is the future, and we are the future. Our Honorable Vice Chancellor, Professor Singh Lather, is a visionary and a passionate leader who fosters academic excellence, innovation, and inclusivity in our university. This Committee on Artificial Intelligence is her brainchild. To know more about the genesis and vision, may I invite our Vice Chancellor to please present the inaugural address.
Good morning, everyone. Good morning. Lovely, wonderful seeing all of you here once again. We keep meeting. Professor Shantanu Chaudhary from IIT Jodhpur, Professor Bhabatosh Chanda from ISI Calcutta, Professor Karthik Dave, Dean Planning, Dr. Nitin Malik, Deans, Directors, faculty, scholars, and I can see many participants here today and some of our guests from outside. Dr. Ruchika Malhotra, Dr. Indu, they are all going to be panelists today. The idea of understanding the role and proliferation of AI in all walks of life, we understand. And we understand in the sense that we started experiencing the benefits of AI in our everyday life. But the confusion arises when we want that how should social scientists be understanding the AI's role into our university, which is mainly a social science, humanities, and liberal arts university. A year ago, we constituted a committee with 7-8 members to deliberate and give us the direction on how should we as a social science university connect to the idea of AI, its research, and we are not left behind by our engagement with the researchers which are happening everywhere in the world. I was just speaking to one of the experts. He told me that we're far more excited about engaging the social scientists into our researches than they are interested in us. So they are also going to be focusing on how our engagement is going to make a difference in terms of drawing that line of collective wisdom which AI poses or gives to us. And after all, at the end of the day, it's artificial intelligence, it is not the real intelligence. So how far the artificial intelligence will go in making difference in our lives is yet to be seen in future. I can recall a film called Terminator, and if we we pick up the example of the film Terminator, it went beyond the controls of the human controls, and we could see that the Terminator was on a mission to killing all humans on the earth. So I hope and I wish that AI is not going to go beyond that, and cannot go beyond that, in fact, because the feelings and the sentiments part of the three elements of behavior, which we call it as cognition, and affection. So the cognition is lot embedded into the AI system. Cognition is again in the action part we see, but the affection part is still to be explored in a lot, very many ways. The researchers are going to do it in coming times. When we saw the outcome of the researches of the fuzzy systems and fuzzy logic based on a lot of data, we see the machines today, the washing machines, which makes sense to us we have the timer, we have the difference in terms of washing the soft clothes and the hard clothes, the silk clothes and the cotton clothes. So this was basically the very rudimentary form of intelligence being embedded into the machines and machine systems. AI integrates into it lots and lots and lots and lots of other things. We know that. But it integrates, it picks up the existing data. It picks up already created information by human beings. So we should not have apprehension, suspicion, and fear about using AI and AI being in social sciences domain. In fact, when we look at the results being given by AI in today's life, a lot of benefits have come in the area of management, especially the supply chain management, and also in the areas of health sciences, where the diagnostic part of the medicine has been far more efficient, precise, and beneficial to the patient. And a lot of collaboration from biosciences, biomedical, bioengineering into AI has happened. So that's going to make a lot of difference in coming times. We know that AI is a tool, but we also know that it can go beyond being a tool. So the experts are here today. I would want those experts to focus whether we are going to be using AI as a tool, or AI as a process, or AI as a machine, or AI as intelligent systems, expert systems influencing all of us. I think they are the right people to discuss and deliberate on the topic. I would like to give little direction based on the committee which was formed on 12th February 2022, and their suggestions as social scientists came very handy to us. While I thought that we should have a workshop of this kind, where we call the experts who can really give us further direction to what the committee had already recommended. I would like to read out few things so that while the experts discuss all this with all of you, they keep this in focus. Uh, Jyotirmay Bhattacharya, he thinks that AI application in routine administrative and personal work would be increased in coming time. And also, it is imperative for the university to start thinking on integrating AI into its processes, teaching, curriculum, and outreach activities at AUD, being a social science university. Then educational material, either online or asynchronous mode, should also be encouraged, so that we can think more imaginatively in terms of our curriculum development. Then Nidhi, she comes from the management side, and her recommendation was that AI and machine learning, big data would be of much use, and they can be leveraged for the School of Public Policy and Management. And I think management is one area where AI is already been uh, welcomed and accepted, and a lot of researches are being happening there. Uh, there was also a recommendation that in MA Economics program, a 4 credit course in statistics and econometrics is offered in the first year. The objective is to familiarize students to machine learning, algorithms, and statistical inferences and estimation. Students get an opportunity to work on data analysis, etc. So machine learning can be introduced in future, and this was one of the recommendations. Dr. Kranti Kumar had shared his current research in the area of noise pollution, traffic congestion prediction, air pollution, relying on big data and predictive analytics, and suggested that issues such as data quality issues, cleaning, and extraction of data are important to be dealt with the teaching and research in the domain of mathematics. The possibility of replacing traditional language support infrastructure with AI empowered language tools such as chatbots, etc., should be introduced in our courses. Uh, Dr. R.C. Sharma, I hope he's here today. Yeah, he's right here. So he's a man who knows a lot of computers. So his recommendation was that AUD's LMS and AI enabled capabilities should be looked very seriously. While Moodle is already used as an LMS, there is a lot of scope in introducing conversational assistants, personalized learning tools, writing assistants, etc. Further, AUD can also explore taking steps towards adopting smart infrastructure integrating several utility-based services such as security, network connectivity, electricity and lighting system of the university and elsewhere also. शर्मा जी यही कहना चाह रहे थे आप? Yes. So Our external member said that AI tools to support pedagogy with the MOOCs and online courses should also be encouraged more in the domain of our social sciences. Dr. Ruchika Malhotra is already here. She said that master's program in data science and master's program in AI should also be introduced at AUD, and suggested that AUD should look at their curriculum to understand the objectives and contents that's more deeply. She also suggested that AUD should consider setting up a center for AI related themes, which can provide centralized facilities to all schools in initiating teaching and research in these areas. Uh, Another expert, Dr. Kapil Sharma, said that AI in various domains and not on hardcore AI part should be focused in AUD. Since several students are not from the technical or science background, so therefore we need to wisely integrate the curriculum and the pedagogy. Uh, it should also be applied to the business school and other social sciences. And there is a close affinity of psychology and sociology to the domain of AI and AI researches that should also be looked very deeply. So, the final recommendation which came from this committee was that we can have an AI lab in AUD, initially utilizing the Cisco lab at KGC campus and eventually converting it into a center. Then creating our own module for internal members of AUD and public at large, understanding what AI is about and ethical aspects of AUD to be considered very seriously. Creating a skill enhancement course for UG students on data and basic programming skills, and also look at the possibility of offering courses on this theme through MOOCs. Starting discussion around setting up a center for AIU seriously. And I thought that since all these recommendations came and we were silent thereafter, so I initiated this workshop for AI today so that we can go deeper into understanding the concepts and application parts. So experts are here today. Do ask them a lot of questions. Do engage them on the suspicion and the fear part, which the social scientists will always have when it comes to technology and its implication. So, all the best to all of you. Welcome all of you to AUD's workshop on harnessing artificial intelligence for social sciences, humanities domain. AI is only a tool. We should not be too scared to apply the researches and knowledge being created by AI. It is not going to be like Terminator in any case. Thank you very much.
Thank you, ma'am, for your inspiring words and actions that have steered our university towards new heights of success. Your vision has prompted us to initiate activities related to AI, and here we are organizing our first awareness workshop. The AI committee is dedicated to more such and discipline specific events in the future. To present further details, may I invite Professor Karthik Dave, Dean, Planning Division, to please share the overview of the AI committee.
So, very good morning to one and all. Honorable Vice Chancellor of Dr. B.R. Ambedkar University, Delhi, Professor Singh Lather, ma'am, Professor Chaudhary, Professor Chanda, who has come all the way from IIT Jodhpur and ISI Kolkata, and other panelists who have traveled from various parts of the country to share with their knowledge and their wisdom on a very interesting issue, which is we can't afford to ignore anymore. First of all, I hope everybody is aware the purpose of this workshop is just to disseminate the importance of artificial intelligence for higher education in general and social sciences in particular. However, AI is perceived to be a threat. There are different school of thoughts. We talk about people, those who are very skeptical about AI and its implication on human society. There are people, those who are very opportunist, and they are trying to leverage on artificial intelligence for the larger benefit of the society. Especially, we are aware that how it is useful for healthcare and other sectors. There are people, those who are realist. They are trying to understand how AI can be integrated in day-to-day life. Industry 4.0 and Industry 5.0, these are the buzzwords we all are aware of. But by and large, we are aware that after COVID, post COVID, we are observing that there is a greater interaction of uh, human and technology is discussed everywhere. And Industry 5.0, what we are talking about, that how robotics, we call it, is going to interact with society, human. That is the area of concern, area of research, area of discussion for all of us. By and large, we are talking about, and whenever we talk about AI, we talk. There are four different ways of AI can be used. We can talk about it's a mechanical use, it's analytical use, it's intuitive use, and it's a predictive use. So we are not very sure that up to what extent we are able to use it in higher education. I was part of one of the very interesting conference organized by Mint and Microsoft, and there they were talking about how AI can disrupt the higher education, and the most interesting part, the role of a teacher in the new environment. The primary role of a faculty member in a higher education institution, I would say there are four important tasks which we do on day-to-day basis. One is assimilation. We talk about how we assimilate knowledge, then how we disseminate knowledge, how we apply that knowledge, and how we are creating the new knowledge. These are the four areas where we are supposed to work upon. And now we have to see one by one that in each area how artificial intelligence and technological intervention can be useful for us, and especially for social sciences, because as I told you, that Industry 5.0 is going to focus more on human and machine interaction. We are talking about neural networks. We are talking about very interesting developments in artificial intelligence. If I talk about my own area, management, we have, or ma'am has already highlighted the role of artificial intelligence in managing organizations, a role of artificial intelligence in managing supply chains, and the area which I belong to, that marketing, when we talk about artificial intelligence, that AI has a much bigger role, because we have a school of human studies in our university, and they know better that how psychological theories are going to be impacted with the advent of AI, how the planned behavior is going to change, how people are going to be different in terms of their preferences, if I talk about marketing. And there the psychological issues will actually impact, because you are programmed. Brands are going to face challenge, because brands are no more there in the memory of the people, because we are relying on more on AI assistants like Alexa, Siri and all, and they are doing job on our behalf. We ask Alexa which particular LCD is good for me, and which size will fit into my room, and Alexa will tell you that this is the best option available to you. So I think there is a need for schools like management, schools like human studies, schools like liberal studies. They all need to come together and explore that how technological intervention, AI, machine learning, they are going to change the rule of the game, I would say, and how they are going to set the tone for the researches which are more relevant and socially productive. So there are very interesting schools, sir. This is for information of our external guest, that we have very interesting schools where we have already applied our you can say wisdom in terms of that how we can make it more relevant for the society. The courses designed at AUD are very unique, and how they can be socially beneficial. But I think now it is time for us to integrate Industry 4.0, 5.0 in our curriculum, so that we can leverage on the differentiation which we have, and we can come up with very interesting disciplinary and interdisciplinary research, and that can be useful not only for academic contribution, but also for policy implications and managerial implications, as well as social implications. So that is the purpose of the committee. As I already told you, this is a wonderful initiative by our Honorable Vice Chancellor. Generally, whenever we travel across, we find that many of the traditional universities, those who are yet to implement 4-year program, which we have done 2 years back, so we are already ahead of time in terms of, and I would like to highlight here, though the faculty members in AUD, they are coming from social sciences, but I have interacted with many, and many of them I found that they are fantastic as far as technology adoption is concerned, that we have witnessed during the COVID times also. They were so keen, and they quickly changed their gear, and they quickly moved to the online education. And I was just reading very interesting book which is written by Vivek Vadhva, Driver in a Driverless Car. That is the future of technology. And in that book, he clearly says that what will be the future of education when we talk about AI intervention. Whether we are going back to the old system of Gurukul, because AI is going to help us in that one-to-one education. One-to-one means Guru Shishya kind of education. Why it is going to happen? Because you will get that personalized, because when we are in classroom, we find that some of the students are completely off track. They are not paying attention to what is being discussed. But AI enabled teaching, the self-paced course, with Dr. Jyotirmay generally use this word quite often, then that self-paced course, I think AI is going to facilitate that part very well. And that self-paced course personalization is going to help student in a much better manner, and they are going to develop themselves, and they will be able to prepare themselves in a much better way what we are expecting from them to do. So I think future of education is really exciting. We are not saying that AI is going to change it, but at the same time there are challenges which all of us need to understand and appreciate. That one of the biggest challenge which I was referring to the conference organized by Microsoft, and that says that what is going to happen with evaluation and assessment of students when AI intervention, chat GPT and all these tools are there. How we are going to make ethical use of artificial intelligence, how we are going to ensure that students are not using any shortcuts or any other means to complete their projects. So I think that that gives a very interesting question to all of us, that how innovative the human mind over the artificial intelligence, how innovatively we use Bloom's taxonomy and other things to come up with a very interesting way of evaluation, which is not only engaging but also very creative and reflective. And I think that is the challenge which we are going to face as far as evaluation and assessment is concerned. So today we are actually trying to know more from our experts. First session, we are trying to know what AI is and how it is going to impact higher education. And then we would like to understand the much bigger role of AI in higher education, and especially in social sciences. And post lunch, very interesting one, that what are the different applications and what are the different avenues for creation of new knowledge in the field of social sciences with the help of AI. Especially we have invited people from technology university, which is very supportive in our all efforts for AI implementation in our university. I would like to thank Professor C.S. Rai, Professor Indu, Dr. Ruchika. They are our members of our AI committee, and they are helping us to imagine and to plan a lot of activities which we are going to do in coming times. And I request all the faculty members to come forward and participate in today's discussion, as well as also come forward and give us a new ideas that how we can organize more number of activities for students and for other faculties in other universities, so that whatever we have we can disseminate, and whatever they have we can learn from them. So it is a big agenda for the committee, and we are going to organize. We are also trying to see that how AI is going to impact the much bigger issue, which is right now the global issue, like sustainability and climate change and all. So we are going to organize another round of workshop in the next coming month on SDG 4 and climate change and other issues. And there also we'll see that how artificial intelligence can intervene and can help. Today I was reading in newspaper that another US is developing another AI system which is actually going to predict the possibility of the new what you call a pandemic. So we can understand the role of AI in our society. There is a contrary and another aspect of it that also we need to understand and appreciate, and because how we are going to make it productive for us, because in other book by Harish Bhatt, the Office Secret says that the distance of technology with ourselves is inversely proportional to our productivity. So these are the very interesting, you can say, paradox, and which we are going to deliberate. And I welcome all once again. I welcome our guest experts, and I look forward to very fruitful discussion and dialogue with audience, not audience, I would say they are PhD scholars, those who are pursuing research, and our esteemed faculty members. So once again, thank you all for joining, and welcome.
Thank you, sir. Thank you for your inspiring words, sharing your knowledge and experiences, and also the roadmap for future events on the related theme. Today's workshop is divided into 3 sessions. The first 2 sessions have distinguished lectures on artificial intelligence for new perspectives in social sciences by Professor Shantanu Chaudhary, Director, Indian Institute of Technology, Jodhpur, and integration of artificial intelligence in social sciences research by Professor Babatosh Chanda, retired professor from Indian Statistical Institute, followed by post-lunch session, which is a panel discussion on the theme Artificial Intelligence and Social Sciences, Exploring Interdisciplinary Frontiers in the Digital Age. As we begin our first session, I request Honorable Vice Chancellor, along with the dignitaries on stage, to please take the front row seats in the audience, please. Okay. We are indeed delighted to have with us Professor Shantanu Chaudhary, who is the director at IIT Jodhpur. Prior to this role, he had a distinguished position at Department of Electrical Engineering at the esteemed Indian Institute of Technology, Delhi, for an impressive 26 years. Professor Chaudhary holds a PhD from the prestigious Indian Institute of Technology, Kharagpur. As an accomplished expert in the field of computer science and artificial intelligence, he has made significant contributions in several key areas, including computer vision, computational intelligence, multimedia systems, and robotics. With a career marked by excellence and a commitment to advancing the frontiers of technology, Professor Chaudhary has an impressive publication record, including 9 books, more than 100 journal articles, and 16 book chapters and numerous conference proceedings. May I now invite Professor Shantanu Chaudhary to deliver his talk.
Good morning. So I'm opening up a very controversial topic that's what I understand. And before I go to my talk, let me just put across certain things in a very clear terms. See, AI will definitely transform our life, and there are very clear indications of that. So how AI will impact our day-to-day interactions with the external world. In fact, today itself, you see that whatever you do on a mobile phone, it's actually tracked, it's interpreted, and based on that, you get recommendations. So therefore, AI has actually reached your bedroom, your dining room, your personal discussions, dialogues, everywhere. Because phones are listening to you in surreptitious manner. And that's a fact, and that's a reality. Although we talk about the data rights, in fact, a government has just brought out a legislation regarding your personal data and personal data rights. But despite whatever it is, this data is being used and AI is using the data. And if you see that when you have discovered petroleum and human at least scientists have understood the calorific value of petroleum, the entire technology changed towards petrol engines, which has driven, I think, number of things in your life, including the car that you're using today. But when you are moving to the space of digital and digitalization, digital is one part, digitalization is another thing. Digitalization is conversion of all your processes in digital domain. So you're generating huge volume of data. So data, as is being referred to, is also a new oil. So if it's a new oil, it's a new asset. And that asset will be exploited in any case. And for exploiting that asset, AI is a tool, or data is being used to create AI. So therefore, if you look into this whole evolution, there is no way you can escape AI. And that's absolutely fundamental. So hence, we have to see where AI can intervene and how we can use AI, or we can develop AI technology, which is very, very essential for economic progress of the country and society. So you were referring to teaching. I think teaching will be majorly disrupted, particularly, I think, the dissemination part of it with the AI-based tools coming in. I think personalized education is a future, because today, if you have experience of classroom teaching, you know, it's very difficult to stop students. I think there are students here as well, looking at the mobile phone while you are lecturing. And if you look at their attention span, since they have grown with your mobile phone, their attention span itself is not more than possibly 10 to 15 minutes. So going from a class of 45 minutes to 55 or 1 hour, I think it's impossible for them to have a continuous attention. So therefore, you have to change the entire pedagogy, and that's imminent. And it is actually being thought about at various places. Even we are also thinking about it, even changing the core evaluation system. Because exam-based evaluation, that what we did and what we have done in terms of questions, assignments, etc. If you see ChatGPT or generative AI are giving tools to the students which are of a different kind altogether. So it's a challenge to the teacher to be creative enough to evaluate methodologies to evaluate the students in a more critical way. And possibly it's not just the individual, what he knows individually, but what is his ability to do things in a group, and all those issues are to be brought in, which actually takes more or gives more emphasis to the human intelligence than use of artificial tools. Therefore, the education is getting disrupted in a major way, and we have to be conscious about it. But what I have chosen as a topic today is AI for new perspectives in social science. I'm not a social scientist at all. I have approached the whole problem from a computer scientist perspective, and as well as dealing with educational administration for years altogether. So if you look at artificial intelligence, the history has been already talked about. It took its first steps in 1950s with the publication of Alan Turing's seminal article, Computing Machinery and Intelligence. And as it was stated, the first use of the term was by John McCarthy in a summer workshop at Dartmouth College in 1956. 1956 to 1990s, even 2000, let's look at 1990s more realistically. The AI was in the esoteric space of scientists, not in common man, but AI was there. And when AI came, that whole concept of AI actually introduced a substantive philosophical and sociological question. What is AI? And that has opened up, I think, first problem that actually people from social science started addressing related to AI. If you look at the basic Turing test, which was proposed by Turing as a measure of intelligence, brought up certain very basic questions. Can machines think? And the problem is we don't know what think means. So this comes via cognitive scientists, comes via psychologists, comes via brain scientists. So therefore, there is a huge issues and questions which social scientists or people who come from social science backgrounds need to address, or not just computer scientists. So therefore, the question is, can we define intelligence? We may say that usually we know when we see it, but what is a formal definition? If it is so, can we tell? Because if we know what is intelligent, then we can say that machine is intelligent or not. And therefore, this is a question which is a philosophy. It's not a computer scientist question. So therefore, social science research agenda has to be linked with what is AI. And this is a fundamental issue which is being debated across. So if, in fact, this is from Turing's paper, that I propose to consider the question, can machines think? This would begin with the definition of the meaning of the term machine and think. So therefore, try to see that this question, trying to answer this question, in many cases, these are philosophical perspectives, not just purely technological perspective. So he proposed this test. So can a machine impersonate a machine? So it's if you see the diagrammatically, what this test mean is, if you see here, see if a person is talking to let's say a computer, and there is another person, is maybe the AI or the person. So you know that when you are communicating across the world, you know that you are communicating with someone who is human. Do you get the same experience when you communicate with computer? So Turing test is if you get the same experience when you are working with computer as that of when you are talking with a human being across the world, then the machine passes the Turing test. That was the Turing's hypothesis. Okay, and when you reach that stage, you know that you have made an intelligent machine. So therefore, the quest which started in 1956 is to build such a machine so that a machine will pass the Turing test. So the first deep investigation into whether machines can behave intelligently helped usher in the field AI, decoupled intelligence from human, and based intelligence on I/O and not entirely look and feel, propose a practical formal test for intelligence. And definitions as tests are operational and easily implementable. So therefore, you see the fundamental alienation which is happening here in terms of intelligence, alienating intelligence from the living being. So it's fundamentally a perspective which is beyond just that of a scientist or a computer scientist. That is separating out the whole concept of intelligence. And now today, if you look into it, all of us use, while we get into a bank account, how to prove to computer that you are human. If you see that Turing was trying to prove that human beings should not be able to distinguish a human and machine, and today on many of the applications, because your machine has become more and more intelligent and able to do things which a human being can do. Say, for example, on bank, machine can actually put in your ID, okay, and maybe guess your password and enter the system. So therefore, as a second protection layer, there has to be capture. So capture is the inverse problem. That is to prove that you are a human and not a machine. Okay, so now there are various challenges of capture. The capture is a research area. Just like the Turing test is, we develop systems to break the Turing test. Similarly, capture is again another issue which is coming up to protect digital assets from machine attacks. So therefore, you may reach such a scenario. If computers start becoming intelligent, computer can be claiming his intelligence is real and ours is artificial. That means machine intelligence is real. And that's, if you see, this whole capture and Turing test are inverse to each other. And hence, this is where things are moving. And therefore, this whole process of movement in that direction, analysis of that, understanding of that, working on its implications is not just that of a computer scientist's job, it's a job of social scientists as well. So what I wanted to touch, the first point is, this AI poses a set of new problems for social science also. Therefore, social science can never ignore AI is a domain of academic work. So let's come to try to define what is today computer scientists mean as artificial intelligence. So human-like, that's a fundamental point Turing had talked about. So say mathematical problems. So if you see, look into it, these are not what we call a deep AI. What is called the mathematical problems, can puzzles, games, theorems be proven? Because they are very mathematical and structured. Can machine do that? Then the question comes, this is the first level of AI, which we are more or less solved it. AI is today actually here in various ways. If you look at common sense reasoning, which is very common, AI doesn't have common sense reasoning even for that of a 3-year-old kid in many cases. An expert knowledge, lawyer, medicine, diagnosis, is its acquired knowledge. And if the acquired knowledge can be codified, then AI system can play a role, and AI system is playing a role in this space. But the social behavior, the social communication, that human being as a social being has special features. So the social behavior of society as a whole and its characteristics, AI is nowhere near to emulate. Although the reference which was made to Industry 5.0, it's also a very interesting departure. If you look at Industry 4.0, Industry 4.0 talked about more of automation on the factory floor, more of a networked production system, and where human being is not playing a major role. But today, the Industry 5.0 is a distinct departure from that, where they're telling that robotics or automation will coexist with human being on the factory floor, on the production system. So therefore, you need to know what are the kind of way that human and automata would interact. So it's an open problem. And therefore, if you say that what kind of intelligence robots should have, so that it becomes much smoother to work together with robo. So the entire space of what is called cobotics came up because of robots working in collaboration with human being. So therefore, social robotics. This is now what is being talked about as social robotics. The point I say, the social behavior of automata. Automata is that AI need not be in a computer itself. AI can be in a physical being in that of a robo. So how the robo behaves with human being and how they work as a team, who sets up those protocols? It's not just a computer scientist's job, because that protocol is dependent on production efficiency, uses of resources, and also the production, control over production modalities, which are fundamental questions with which even that capitalism and communism came up with the issue of surplus value, dealing with surplus value. So today is with robo and human being co-working on a floor, what would be the concept and definition of surplus value system? And in fact, these are the questions which are coming up with a new challenge of Industry 5.0 as a concept being talked about. So again, I'm talking about is not that social science can be away from all these questions. So machine learning is what? All of us, we talk about machine learning is essentially, I have data. I learn how to explore and exploit data. And there are algorithms and techniques for that. That's ML. There's a group of people who will work on defining and designing ML systems. There'll be a group of people who will be using ML systems. And today, if you look at, even in the industrials, we talk in terms of people who simply applies ML, somebody who actually develops ML. The social scientist's role in many cases actually to provide inputs, relevant inputs to developer of AI, but also a fundamentally user of AI for their own problems. Because none of the social science problems are without data. You collect data through variety of surveys. In fact, survey, and if you see today in economics, RCT, in a social sciences, number of sociology areas, you actually carry out survey for basic hypothesis to be verified. So that data that you collect, the way you sample, that all of these things is giving rise to the quality of the data, issues related to the quality of data, and with quality of data, tools to actually ingest that data. And AI, machine learning are nothing but tools to ingest those data. And today we are so excited about deep learning because now with availability of computing resources, today AI and the machine learning can actually do much better job. Put it very simply, if you look at with the basic knowledge of statistics, it's a question of actually understanding the distribution of the data from few samples. And there are parametric estimators which estimate the distributions. But when you talk about AI and AI techniques like neural networks or deep learning, these are in various ways non-parametric ways of estimating the data distributions. So when you do a survey, you are sampling the data space. Now, based on the samples of the database, if I can estimate the distribution in a non-parametric way, then we have a better insight onto the nature of the data. But at the same time, I think all of us know the statistical distribution shift. You are referring to, say, pollution study with the sensors. All the sensors that is used for pollution measurement based on temperature, moisture content of that point of time in the year, the sensitivity and the calibration of the sensors drift. So there is another very fundamental problem is distribution drift. And therefore, ML can work as long as there are no drift in the distribution. Classical ML. The way today deep learning is framed, classical other machine learning techniques are framed, they really give you what? A mapping between input and output. And these machine learning systems, for us, for many of us, can be considered as a black box. And once we give data to that and allow that system to learn based on the data samples, it actually learns the distribution. And since it learns the distribution based on the new input, it can predict what would be the output. And that's simply predictors are what are ML systems. But predictors are not just intelligence. Intelligence is much more than that. So what we are talking about and the AI tools that we use today are nothing but examples of shallow intelligence. That simple prediction of predictors. But deeper intelligence is fundamentally required. And deeper intelligence, one of the basic point is the drift. Say somebody can recognize me today, but even after 20 years, when I have more graying hair, that same person would have the ability to recognize me. So human brain ability to recognize or classify is invariant to drift. So today's ML is not invariant to drift. So therefore, the whole search is for new generation of technologies which can really address the problem of drift. And probabilistic causal reasoning is because we all reason. With any phenomena, we all reason. So the whole question comes up, can ML and reasoning be combined together? The moment that gets combined, AI becomes very powerful tool even for social scientists because you can discover the inherent causality embedded in any social phenomena that you analyze. So therefore, discovery of the causal framework is actually the current new trend in AI which is coming in. And what is called structural causal models, which can deal with the causality. Causality is also linked with counterfactuals. And how to deal with counterfactuals? With the counterfactuals, how do you build up a consistent causal framework is actually the new AI looking at. The other part of it is what we talk about is your generative AI. The ChatGPT-4 is an example of generative AI because ChatGPT-4 has got access to huge volume of data which is there on the internet. And exploiting that whole set of data, generative model is, as I've told you, if I know the distribution, given an input, I'm doing a prediction, but also at the same time, if I know the distribution, I can generate new samples belonging to the distribution. That's essentially the generative model. More sophisticated version of generative model is, can I combine multiple such distribution to create data of a new distribution? But today's the standard generative model, GAN model that we talk about in AI are fundamentally knowing the distribution, can I generate a new data point which belongs to that distribution. And ChatGPT is exactly doing that. If you see, fundamentally, I'm talking about more intuitive way, not going into the mathematical foundation. You have huge volume of text data. The transformer model, which is used at the back end of your ChatGPT, are what is called unsupervised learning model. Therefore, you don't need a supervision to understand the text. So if he has a huge volume of text, so I can know that generative model knows how to construct sentences correctly. Fine, because another sentence of that language is nothing but another point in the distribution. Fine. Therefore, when you give a query, it picks up various data which belongs to that domain, puts them together, and synthesizes a result to you. So it can even write a poetry. But the fundamental point is, I don't know how many of you have checked with the hallucinations by ChatGPT. Fundamentally, hallucination is what? It synthesizes and generates a report, a write-up which is not true. Because the moment you start synthesizing things which are available, you also generate garbage. So hallucination is generation of a garbage. Because fundamentally, you have to look into it. In fact, there are lots of, I think, faculty would be here from philosophy as well as psychology and cognitive science. The meaning of a word is really has a grounding. If I say red, red is linked with the grounding of objects which has got color red. Red as a word RED has no semantics. The semantics comes only through grounding. So what ChatGPT is doing is actually doing a syntactic generative model, and not the grounding is essentially missing. So the truth part of it is actually missing in ChatGPT. And ChatGPT can generate all kinds of hallucinations, and that can actually be very, very dangerous. So it can be as dangerous as atomic bomb. Okay, it's very serious threat, and that's exactly the point. Is if you talk about threat of AI, is if the ChatGPT used by a propaganda machine, it can be as dangerous as Goebbels of Hitler. So that's why I think if you have seen that Hinton has resigned and said that he would not be like to be part of OpenAI. So I think these are the threats of AI. But those threats are of a different kind from what AI is becoming part of our life. That's what I want to talk about, is by threat, on the basis of threat, we cannot run away from AI. We have to be in AI. We have to explore and exploit AI. So AI as a research method, therefore, which comes in as an implication. I think how much time I have got? Another 10 minutes? Okay, fine. So I'm coming to the next part of it, where AI has taken some of the material from one of my colleagues. She'll be there in the afternoon. So AI as a research method in social science is today very well established. In fact, computational techniques or data science techniques more than AI techniques, because data science is a superset of what we talk about in AI. And in fact, we have observed, I'm talking about a perspective what we had gone through at IIT Jodhpur with our liberal arts faculty as well as computer science faculty, that it's absolutely true that AI is changing the way social and human sciences model and analyze their data, understand their objects, and visualize their results. In fact, this process had started about 4 years back. And we have actually developed 2 programs which are not very specifically AI-centric, but definitely digital and data-centric. We have run a program, an interdisciplinary research program with MSc and PhD in digital humanities. And also we run a program on computational social science, both MSc program as well as PhD program. In one case, in the digital humanities, primarily we are looking at the space of humanities, the literature, and all other the creative arts or traditional arts area, where the digital techniques and digitalization is coming in a big way, and how that can become a formal kind of an academic, can be brought into a formal academic framework. In fact, digital humanities is globally a subject today. In fact, multiple universities, even in India as well as abroad, are engaged in digital humanities. So we have a program in digital humanities where there is definite crosstalk between uh, humanities faculty as well as computer science faculty, data science faculty. So therefore, it's an interdisciplinary way things are done. In fact, same thing is true for computational social science. In fact, actually, we have created in the School of AI and Data Science a group of computational and mathematical economics who actually make use of all these data science and AI techniques and variety of them for a number of problems. So therefore, we have actually in our academic ecosystem, since we have the advantage of having a stronger crosstalk between the people coming from science and technology with that of social science as well as other areas. So that helped us in building that program. In fact, our MBA program, we have got MBA Tech, which is primarily a very large usage of data science and AI in the management discipline. So therefore, it's definitely an advantage to have a kind of a multidisciplinary architecture of a higher learning institute to bring in these kind of a transformations. Because whatever I shall talk about, if I say AI is a new tool for statistical data analysis, text and language analysis, network analysis, image analysis, and many more, they can only happen if there is a collaboration between the people coming from two different disciplines to start with. Subsequently, if people are coming out of that background, they will pick it up and they will do things on their own. So look at statistical data analysis. So machine learning is being increasingly used to vast quantities of social data being generated from and about people. So I have picked up cephalogies, how cephalogists use the data. So one is that accurate forecast. In fact, it's actually a documented study of US elections. To provide accurate forecasts of state level polls in US elections. Even here also, I think we are very familiar with the cephalogists working on that. And they are today increasingly using ML in terms of prediction of these kind of poll results. Then character development in novels. Now, if you actually want to say that over 30 years, how the main protagonist, say main female protagonist of a novel has changed its social position or the perspective. Now, 30 years of novel analysis is humanly impossible for a researcher to do. But if it can be framed as a data science problem, then there can be various insights can be discovered which cannot be done by an individual researcher. In fact, people have done such work and they are all reported in literature. Then better understand the structure and demographics of city neighborhoods, because that's also important when you talk about city planning. So if you look at from a perspective of planning, the city planning or the planning as a discipline when they're looking at, so therefore ML and analysis of this population data is something very, very fundamental. So the data analysis becomes an integral part of many of the social science activities. And in all of these, fairness, accountability, and transparency is a must to avoid what we call pseudoscience. Why? I can actually pick up data the way I want to, okay, with bias, and I can propose something which may be dangerous. And this is a tool for various political dispensations to actually explore and exploit. And that's the danger of it. So the trustworthiness, fairness, and accountability of the data, the way they are being used and to be used is important. Because, see, the point is, this is not something new. If you look at that has happened in social sciences at various points in time, all this study did not be actually without bias. They can be with a predefined objective, those studies can be defined. So therefore, one more important point to be understood in the context of social science is this definition of fairness, accountability, and transparency when you're talking about ML. So then text. Text is another major thing to look at. Because as I said, that literature-wise, there is huge volume of text which is there, and all of these that I've talked about, information retrieval, text classification, linguist and semantic annotation, information extraction, authorship discovery, these are all problems of digital humanities, where AI is being used in a big way. In fact, topic modeling is this is linked with automatic classification of documents. And I shall just touch upon topic modeling later on, but see what vectors, automatic annotation, discovery of named entities, sentiment analysis, all of these, there are computational tools today to do that. In fact, what ChatGPT is doing in terms of these transformers, and actually the generative model, these are part of what we say in AI, natural language understanding. Natural language understanding is turning out to be a very major tool to interpret text. In fact, actually, see, if you enter the social media analytics, is lots of textual analysis, and based on that, making conclusions. And making another last part, which was referred to earlier also, making possible new quantitative or quali-quantitative. That is, what we are talking about is, what is quali-quantitative is that you do qualitative studies as well as quantitative studies, both. Because it's not just quantitative studies, what we talk about in terms of ML, but qualitative studies is also part of symbolic reasoning, which is also part AI deals with. And so therefore the text analysis of text and considered as data for contemporary culture or cultural history. In fact, this has marked, I think it was referred to in introductory remarks, birth of a new discipline called culturomics or cultural analytics. In fact, it's all cultural data, this analysis of cultural data and their usages. Topic modeling is algorithms determine abstract topics or themes in texts. So therefore, it has to be cross-correlated. I can use an algorithm to identify the topic, model the topics which characterizes that text, but it has to be cross-correlated with an expert in that domain to whether that is correct or not. Because the topic modeling, the advantage of this topic modeling is I can use a huge volume of data for doing topic modeling, and topic modeling is also a tool for culturomics, but cross-validation is very, very important and critical. So this is an example again of arts funding. So this is, if you look into it, if you talk in terms of a funding trends, the funding documentations are linked with various topics which have discovered, and they show a temporal trend. The temporal trend analysis also tells us how the perspectives have changed in terms of funding, how maybe political perspectives has come in and influenced the funding patterns. So AI for developing academics, which is actually, I think, Dipabhuti's work. She will talk about it later. This is infant malnutrition, clean water access, and government interventions in India. A machine learning approach towards causal inference. So they are here, actually the causality plays a major role, not just simple ML. And this analysis, I think she figured out, this is actually a discovery. If you see, it establishes that clean water is one of the most crucial issues to focus on in terms of dealing with malnutrition. And therefore, this study is completely based on data. And I think she may refer to more such work, because I think a large number of these AI-based tools and techniques are being used in this space. Image analytics and art history in particular, taking advantage of AI algorithms to develop new approaches to understand life of forms and evolution of motifs. The works of art are grouped according to similar motives and visual references. So people who work in art aesthetics, today AI is a very important tool for them. So heritage, because the entire management of heritage and management of heritage, today AI-based analysis is a very important tool for heritage data. And if you look into it, therefore, digital heritage is heritage in the digital space. In fact, actually, if you, it was also part of G20, this declaration of the Science 20 part of the G20 is preservation of heritage globally. And preservation of heritage globally is that using digital tools was one of the declaration of that. Okay, so digital tools for heritage management is becoming a very critical element globally, and there also this whole global understanding. In fact, what we talk about digital twin of heritage objects and how the digital twin can preserve heritage object against all kinds of attacks. In fact, this is something is also a diplomatic challenge. And with see, if you see the Bamiyan Buddhas were destroyed, so the human heritage to be preserved, so there has to be in the digital form and digital space. So AI in heritage science covers a full range of heritage-related activities, from investigation to conservation, management, education, and communication. And therefore, here the science and society gets linked together. So therefore, social science has to be an integral part of it. Cyber archaeology. Cyber archaeology is another very interesting thing. Is that see virtual archaeology? That archaeology, what we just talked about, digital heritage, is a kind of a virtual archaeology. Archaeology in a virtual space. Cyber archaeology goes one step beyond that. What we say, cyber archaeology is a process of reconstruction simulation. So therefore, if you say the history is based on various hypotheses, even architecture is also based on various hypotheses. Now, can you build a simulation platform for those hypotheses to be verified based on the ground truth and other circumstantial evidences where AI actually drives the simulation process? And that creates a new space, new area of what is called today cyber archaeology. So cybernetics of archaeology refers to all interconnective relationships, data, knowledge, and possible hypotheses, and simulation for this purpose. So how do you generate knowledge by cyber simulations in digital ecosystem? So as simulation starts playing a role, now the cyber archaeology that I'm talking about using AI, it also comes in variety of other disciplines as well. Starting from, say, your health policy. If you want to take a initiative in health, can I simulate the future in terms of the models that I have and built with the existing data? Because AI primarily works on predictive models. So if we have a data-driven predictive model, can I use that predictive model in conjunction with simulation to actually estimate what will be an effect of a public policy in future? That gives me a quantitative estimation of possible effect. So therefore, the social science becomes much more exact. So in fact, I think all of you have come across this terminology of exact humanities, which is also a discipline which is coming up in various ways. So therefore, I just would like to show you some examples. Let's say this is the data you get. Okay. Now, when you don't get data, you have just photographs and also a set of photographs, then you can generate 3D models using lots of AI-based tools. So therefore, the things which are already lost and which is not there, let's say this I don't have the top of the chariot, but if I have these models and we have these architectural rules of the styles of those days, based on that, you can do an hypothesis of how it was and it would have been. And then if you simulate in a structural consistent way, then you can also create an hypothesis of things which are lost, but what could have been. So what do we say? The counterfactuals you can create through AI in the space of heritage and can actually, in fact, this also gives to very interesting space in history to explore. Okay, in terms of historical events, that the impacts on society. I've shown that example of architecture that can be anywhere as it is. So if you see, this is what we try to do in terms of hypothesis. Can we create a kind of a 3D model and even a 3D printed model today, and actually to justify whether there is a measurement of these parameters, etc. So again, this is other examples. So I want to give one example here. We have all seen that a number of these kind of sculptures have been mutilated under different conditions. Now, this is an example where AI has been used to hypothesize what it should have been based on the style estimations of other such artifacts which are there today in an undisturbed way. So therefore, from an art history point of view, from digital preservation point of view, AI has a very major role here to play. In fact, this is again inscription images. If you want to read inscriptions better, in terms of any study, AI comes in as a tool to provide you better readability of inscriptions. And if you see, this is also editable text with transliteration also can come in, which can makes it more accessible for researchers to look at. So these are AI as tools. And this is another example that if you say that digital twin, I was talking about digital twin predictions, these are recreation of the past. It's an interesting video. I just, if it plays, I would like to show. See, this is actually a temple of Humpi recreated in 3D and a dance of that time recorded, projected in 3D. And you can see this actual being performed in that space. This was a part of an exhibition we did in National Museum in terms of Hampi and the data and what we had in those spaces. So I'm just skipping this. I think time is over. So this is another historical thing is that this is a Parmar and Chauhan rules of Kiradu, and that history is almost not there today. But those temples are there, and based on those temples, you can create models and you can preserve the temples. Also, at the same time, you can actually study that lost kingdom and the data on the basis of this AI-driven analysis. And this is the last point I want to touch upon is human-centered AI, the question of human-centered AI. AI has an ethical issue. AI as an ethics is a very fundamental point in research area, which computer scientists will not engage in, but people coming from philosophy is supposed to get engaged in. And what will be really the ethics of AI? And today we talk about AI, but at the same time, we all know from philosophy what is wisdom. We know from psychology also what is wisdom. And there is an entire set of area which is coming up, which is called artificial wisdom. Because when we talk about AI systems, we really do not talk about how the system would do well for the people. Let's say, for example, if I say an autonomous car. Autonomous car design just talks about the route. And if it has to have an accident, what is the ethics of that accident? Will it kill itself or kill the person on the road? If it kills a person on the road, will it take the chance to kill an older woman or a young man? Now, these are ethics questions. If you look into it, there is what is called a moral machine, is an example which has been set up by MIT for ethics researcher to experiment with. Because you can create those ethical dilemmas and put onto a crowd behavior, that how crowd react to those ethical dilemmas. And that actually helps you to understand what is the public perception of ethics. So it's not for computer scientists. Computer scientists have used a tool which is actually a very interesting research tool for the people working in the space of ethics. And therefore AI ethics is something is very, very important and critical, and it's being globally talked about. It's also part of agenda of World Economic Forum. So I think social scientists can really take this up, and that should actually contribute substantially to the field of AI itself. Generative AI and social science, that high-level term demarcates a shift of machine learning that it can generate lots of scenarios. As I talked about, ChatGPT is an example of generative AI. And using large language models, using vast amount of text-based data, which identify a probability that a word will occur given the presence of other language patterns, and therefore it generates the words, but those things may not be grounded in truth, grounded in physical reality, and hence it hallucinates. hallucination is a major problem today. AI researchers are engaging with the generative large language models. And therefore, what is a Turing test? I started with Turing test, I shall end with Turing test. So when we have the generative AI, what is a Turing test? See, those example studies to papers in 2022 and 2023 studied whether research participants could differentiate short statements about US foreign policy generated by LLM, large language models, and humans. Another study was whether a human survey respondents could discern whether text about job postings and online dating profiles were created by humans or GPT-3. And the result was it couldn't. Okay? So, therefore, if you see today, have we gone far beyond than Turing test? That means, are we generating a really reached an intelligence where this confusion is coming up? Is it machine or is it human being? Machine can tell you that my intelligence is natural, uses artificial. The cartoon I showed that this is where possibly we are reaching. And that's the what is called the philosophical crisis and technological singularity. Singularity point where this, what we say, the speculation concerning first ultra-intelligent machine. And therefore, there has been lots of literature, the law of accelerating returns by Ray Kurzweil. It's a very famous book, the singularity point, and singularity is near. In fact, there is a called Singularity University who talks about reaching to that singularity at a forum, a physical as well as on web, which talks about what happens in such singularity point, where machine becomes more intelligent than that of human being. But these are all hypothetical scenarios. Okay? Obviously, we are reaching somewhere near the tipping point. But despite the tipping point, it's always true that human intelligence, the emotional aspect of human intelligence is something still untouched. And what is missing is, in overall thing, is that what is wisdom? A person with wisdom will not do anything which is wrongful or harm anyone. AIs do not have that capacity. The entire shift, what people are talking about today, in fact, I think wisdom is an area where philosophers and psychologists work on. And that artificial wisdom is what even AI studies are talking about. Not just intelligence, but wisdom, that system should know what is good, what is bad. Today, AI system doesn't have built-in ethics. So if I have to have AI systems with ethics, then obviously it has to have wisdom. That's an open space. And if we really want to create artificial wisdom, it cannot be a computer scientist or technologist's job. Okay, so there has to come from the softer side that whole definition of wisdom and how that can be realized maybe through a technological process. So there the crosstalk between social scientists and technologists and computer scientists is so very essential for a positive direction of growth of AI or the new data science. I think that's my submission to this August gathering. Thank you. Any questions? I shall be happy to answer. Yeah.
Thank you for a fascinating presentation. I'm just wondering whether any work has been done on the basis of artificial intelligence. I mean, if you look at my motorized wheelchair, I think in some senses it is a part of whatever development in that sense. But how does it happen to, intellectually impaired students and, who are trying to kind of, go ahead? Has any work been done on that account?
Yeah, actually, there are quite a few things which are happening. See, there are various kinds of ways that disability issue comes up. Say, for example, look at blindness. I'm talking about very specific things where work has happened.
Yeah.
Look at blindness because many of the blindness are reversible blindness.
Yeah.
And there is a project which is going on in collaboration with MIT of these early childhood operations of cataract. So if you remove the cataract, then at the age of 7 or 8, people get back their eyesight. Now, as they get back their eyesight, so then from that age where their brain has matured, that whole visual senses develop. So that provides also a treatment, in fact, AI-based treatment to how accelerate that process. And also at the same time, that also gives a very important input to understand the visual pathway. So if tomorrow somebody has to create an artificial retina and how the pathway has to be plugged into these pathway, these nervous pathway, that input comes up. So if you see, this is a very interesting way where
somewhat tight jaws also.
yeah, tight jaws also. So something like, see, this is where actually very importantly, the brain science, AI and rehab processes, treatment, join hands to do something good for human being. This has also been done. If you see, there's another project which is called Walk Again. The people who undergo accident and get below the waist paralytic, but the brain walks. Now, how you actually can do the brain signal transmission and treat them to be able to move their lower limb. That is a major AI and brain science based project which is called Walk Again. Okay, so there are many such projects that are happening in this space.
So if there are any readings that you could kind of suggest, I would love
I can pass on to Indu, so maybe she can pass on.
Thank you, sir.
Sir, you spoke about intelligence in the beginning and wisdom at the end. I want to ask about something in the middle, understanding. That in social sciences, we are interested not just in the input output relationship, but also understanding in some sense of why it happens. So, the way Turing test kind of delinks intelligence from humanity, is there some methodology of delinking understanding also from humanity? And then can we say that machines understand and can they share that understanding with us?
Yeah, so let me just come to this point. So that's why I said that the Turing test explicitly disengaged intelligence from a living form, if you see from that point of view. But what you are talking about, your question is in terms of the question that is that the mechanism. See, ML, I told you, is an entry point which talks about that mapping. But the causality is what you would like to discover. So that's why I gave examples of causal networks. The entire structured causal model, where the work is happening right now, where it gets combined also with generative AI, is actually the paradigm which people are trying to look at. How do you understand or discover causality in the data itself? It's not just a mapping, but why the mapping is happening. That's a causal framework. And with these, I think the brain science has a huge role to play. In fact, people have actually, many of the techniques, in fact, if you see the convolutional networks, which is actually, which is being used for your deep network applications, the whole motivation of design of convolutional networks is a biological architecture of human vision, the entire visual pathway. Okay, so therefore, brain science have actually worked as an inspirational context of many of the AI techniques being developed, and that's being used today. If you see, the brain science, AI is supporting brain science exploration. Brain science is supporting new AI tools. So that communication is very, very fundamental.
Professor Chaudhary, I have a question. The language bias in AI data augmentation, it brings in the cultural bias as well. Are we addressing to this question now in AI?
Yeah. So the whole area of what is called trustworthy AI. In fact, I have a talk in the afternoon in another gathering. I am talking about trustworthy data. So trustworthy AI is something very, very important which is coming up. So therefore, how do you address bias? How do you address fairness when you design AI system? And more than that AI system, how to look at those things in the data itself. And that is something very, very fundamentally important. And the second thing which comes up is AI systems can also be attacked and can be attacked to behave in a biased way. how to protect AI system. So therefore, these are actually concerns. I have not touched those things because they are more closer to computer science approaches, how to make it fair, bias-free, and entire area of what we call today trustworthy AI. The whole focus is today, it's not just in AI algorithms, but how to make sure that AI system that we get is trustable.
Thank you. In fact, it's related to Jyotirmay's question. I was thinking that when you're talking about large-scale data in social sciences, it's very clear from the way is very fascinating. But I was just thinking that as a social scientist, now we often use a small data set, a very small sample. Say it's drawn on the basis of purposive sampling, all right? And in that case, suppose in a firm, now from the industrial organization point of view, I can now deny that firm is no more a black box, but is actually a nexus of contracts. Now, suppose I want to understand the impact of technological modernization on these nexuses of contracts. How will I use because my sample is very small and I'm just looking at a kind of, I'm trying to understand the process. So how AI will actually facilitate, while a large scale thing I understand, but this is a bit confusing for me. If you can.
Yeah. See, I have not used big data problem at all. I have not used the word big data. Why? Because today there are a number of techniques which work with small data. In fact, one thing is there is a set of techniques which are called one-shot learning, multi-shot learnings, and not really big data learning. Those are like very small sample-based data. There's a whole range of techniques which are coming up in the small sample-based data. In fact, actually, the GAN that I referred to as Generative Adversarial Network Model, there the whole approach is also using small data. Can we really estimate the distribution and generate samples from that distribution? So, yeah, hypothesis to actually verify, and then based on that, can you do that? And it's not that you can get labeled data. Typical machine learning talks about supervised learning. You need not have labeled data. The entire transformer technology, which has actually even LLMs are using, is completely unsupervised. So therefore, there's a huge change of, if you see last 5 to 6 years, the whole framework of ML. Okay, so therefore the small data problems people are working on, there are tools and techniques available to address those problems. So one-shot learning, then using of transformers, multi-shot learnings, even generative models to deal with small data. So you'll find a number of publications coming up in that space. And also, it's not just it's not just technical, but also social science-based applications. They're also talking about that.
So I was just wondering whether with this artificial intelligence and machine learning, will we be moving a step forward in terms of deciphering the elusive Indus Valley script, which connects?
I think it should. It should. It has to be proper. The point is, proper research program has to be designed. In fact, this point I had also talked about in some of the other forums. That can be addressed, because see, the script does not evolve from the air. There's an evolution component to it. Now, based on that, can we do a kind of a generative model for those examples creation and see whether we can fit that back in a kind of a system? So it has to be an appropriate research project defined, where people from archaeology who are actually is into this older script analysis, and also computer scientists come together and work in a kind of a collaborative fashion, because many of these challenges are actually has to be solved in a collaborative way. In fact, the example I showed about the Humpi, it was a collaborative project between computer scientists and the people who came from architecture and archaeology background.
Yeah, it was an inspiring talk. My question is, how is this AI actually going to address the idea of democracy of the powerless
and whether there are any equals in the system, because finally it is going to be Intel, Microsoft, many other who will be actually benefiting from the whole frame. What happens to communities, because there is a whole thing in which suddenly all humans are very rational and efficient and very, very good, and there's no politics and there's nothing, everything is very well.
It will not be like that. So
So where is the space for human error and destructiveness that we are always capable of? So is there any way of thinking around that through AI that really makes us less hierarchical? Will there be a death of politics? Will we not need any of these ideologies to work when we really govern as very rational human beings? Because it's really a potential site. So just curious if any thinking is there on that line. Yeah. Thanks.
see, actually, there has been. See, if you look into it, see, let me say that AI can democratize really the whole system. The question is, just like you talk about the ownership of production, you need to have ownership of the data. Fine, data is a capital. If you have a distributed ownership of capital, then actually the whole system becomes much more democratic. Today, what we are talking about is for Microsoft, Google, etc., because it's a data who is having the data. And just take an example, let's look at this way, is also the policy of the government. Today, with your DPI, the digital public infrastructure in place, what is happening, all of us are leaving huge amount of digital footprints. Digital footprints are also digital capitals. Okay, now who has the ownership of that footprint? If you can resolve that issue of ownership of the footprint, then you can democratize the whole data economy. In fact, that's actually where I think the people from economics, social science, and political science can really contribute and build up that theory. And theory, not only just theory, that can be the next revolution altogether.
Okay, we can have.
Can I just?
There's so many questions coming up, but we have paucity of time. Sir has another session to attend at INC. So, thank you, sir. Thank you. Your presence and insights have greatly enriched the event, inspiring our participants and reinforcing our commitment to academic excellence and innovation. We are honored to have you with us today. May I request our Honorable Vice Chancellor, ma'am, to felicitate our esteemed guest, Professor Shantanu Chaudhary, as an expression of our gratitude.
Slightly odd.
Next question. Thank you. Thank you, ma'am. Our next session is on the topic Integration of AI in Social Science Research by Professor Bhabatosh Chanda. Professor Chanda is a retired professor from the Indian Statistical Institute, Kolkata, and a visiting professor at Indian Institute of Information Technology, Kalyani. With over 40 years of experience, his research spans from digital image processing, pattern recognition, computer vision, mathematical morphology, to AI techniques in computer vision. Professor Chanda has supervised 16 PhD students and received numerous accolades, including the Young Scientist Medal from the Indian National Science Academy and a UNDP Fellowship. He was also awarded a Diamond Jubilee Fellowship by the Indian National Academy of Science and a postdoctoral fellowship at the University of Washington. His achievements include the Computer Engineering Division Medal awarded by the Institution of Engineers India and a recognition such as the Vikram Sarabhai Research Award from the Physical Research Lab. He has authored 9 books and close to 100 research papers, earning him several accolades and fellowships from associations such as National Academy of Sciences, the Indian National Academy of Engineering, and the International Association of Pattern Recognition. Most recently, he was honored as a fellow of the Asia Pacific Artificial Intelligence Association. I'm pleased to invite Professor Chanda to deliver his talk. Sir.
Good afternoon, everybody. I have to thank many people here. First, to start with the lady, give a introduction, lots of things talk about me, and I also thank the organizer to invite me to talk in front of this completely different kind of audience. Okay, I usually talk in the computer vision, computer science people. Right, here's all the social scientists. Okay, there's a completely different experience. Okay. I should also thank all those whose material have been used to prepare these slides. Okay, a little bit from my contribution, but most of the copied from here and there. And I greatly acknowledge the contribution of Professor Shantanu Chaudhary, who gave the extended introduction of my talk. In fact, when Professor Grover sent me the program, and I see the Professor Chaudhary's talk preceded my talk, I ran in my slides, okay, and substituting some of the things I know he is going to cover. And since it's a heavy philosophical talk, so I choose to be on the lighter side, okay. So this is the outline of the talk. Introduction was already done in the previous lecture. Here I will talk about some of the keywords used in the title. There is the artificial intelligence, social science, etc. Then I will go for the history of the AI that took place already in the social science. Okay. And exploiting this AI, how they exploiting AI as an assistant to social science research or the social researcher. And then I'll talk about some of the AI tools so that you can use them in future whenever you need. Okay. Then some concluding remarks. Okay. Shantanu has already told that it's a very difficult, intelligence cannot be defined. I would say it's really very difficult to define what is intelligence because it's a complex, multifaceted trait of human beings. However, two major aspects associated with it. Number one, there is a logical derivation. Already Professor Chaudhary mentioned is a shallow intelligence that's used in the theorem probing, game solving, puzzle solving, games, etc. Another is a efficient information retrieval. Okay, whenever you go to your friend's house or your relative's house, there is a small kid comes back and ask him to, okay, tell what is the rhymes you've learned in your primary school and this, and he starts with the twinkle twinkle little stars. It's immediately is the intelligent boy, okay, or some number table of the multiplication table, etc. Immediately can say is so it's not nothing logically derived. Yes, he or she has already learned it, memorized it, and whenever you ask, even your students, whenever ask a question, if he immediately answers it, is intelligent, right? So it's a majority part is the information retrieval. And most of our intelligence activities, either of these two or the combination of these two. Okay. So all the consonancies, summarization, adaptation, generation, even the creativity is based on these kind of activities. Okay. So AI, basically we try to simulate this kind of activity, this kind of characteristics into the machine, particularly computer, so that it can take appropriate steps or appropriate action which requires usually human intelligence. Okay. And that's all about the AI. And so this AI can be overall can be represented as a global set of the activities. A significant part of that, the already Professor Chaudhary mentioned, is a machine learning. There's a basically the development part. We are developing the algorithms or techniques or methods, is a coding it, etc. And to note that majority of these machine learning techniques are nothing but the applied statistics. Unfortunately, this statistician could not sell it properly. We, the engineers, could sell it as in the name of machine learning of the artificial intelligence. Many of the tools, in the data science, data analytics, machine learning, AI, everything is applied statistics. Okay, and now we have another very special subdomain of the machine learning. We call the deep learning, where the machine can take absolutely raw data, the measurement of the observations, and in natural form. And for example, there's convolutional neural network, large language model, generative adversarial network, etc., and can produce the prediction or generation or produce something. Okay. This is the AI part. Social science, what I understand. My God. Oh. Okay. Social science, what I understand is nothing but the academic field of academic study of the human behavior, societal behavior, and the relationship between these two, either individual or in group, and it has many branches, right? Uh, so to model or to predict or even explain the pattern of this human behavior individually or collectively needs the gathering of the data, analyzing them, and predicting something. Okay. So in that way, what this AI or machine learning does, all the social scientists are also doing the same thing, gathering data, analyzing them, and based on that predicting something in future for the future. Okay. And here the some of the subjects, not an exhaustive list, put in the alphabetic order: anthropology, archaeology, economics, etc., up to the sociology. Okay. Now I have to thank Professor Indu. Okay. Without whose persuasion I would not be here today to giving this talk. When he first approached me, I was a little apprehensive that I am from the computer science domain, talking about researching about the AI or the machine learning or the computer vision, and I know nothing about the social science. What do you talk about? That's gathering. Okay. Then I realized that let me give a chance. I asked him 48 hours to give me my consent, yes or no. And then I go back to studying the field over the internet and the library and found that telling about the AI or the machine learning, the social science people is lying like carrying coal to Newcastle. They are the founders of the artificial intelligence, the machine learning techniques. Right? Let me give an example. Let me introduce this gentleman, Lord Francis Galton. By the way, he is the first cousin of Charles Darwin. Oh, you all know, right? They have the common grandfather. The Francis Galton is popularly known for his contribution to eugenics, behavioral genetics, and anthropology. But in 1884, he set up an anthropometric laboratory in London. And there he used to measure the human features. Okay? And from there, he collected the family height of the parents and the children, adult children, right? And tried to correlate this data not with the single parent. He converted the father's and mother's side to make it a mid parent height by a weighted average. Father side into 1 plus mother side into 1.08. How this 1.08 is a first step towards machine learning. Though there is no machine for him, he did it manual calculation over and over again, and gave the formula of mid-parent height is the father side. And the data he collected on the left-hand side table, the first column is the family number, the 111. There's a 4 kids. Okay, all have the same father side, mother side, and these 4 kids at the adult kid has different height, their gender, and okay, all are noted. Okay, then he calculates the mid-parent height and regress this data, this mid-parent height of the child's data, and got the curve on the right hand side. These are basically he called the regression, and which shows if the mid-parent height is more than the average mid-parent height, then the child size would be lesser than the mid-parent height. If the average height is lower than the mid-parent height, then the children's height will be more than mid-parent height. And there's a linearly correlated. Well, I'm not really interested in what is their found and what is their experimental result. We are interested in this the first, at least to my best of my knowledge, there's a first experiment that's anthropological data is analyzed using what we call nowadays a machine learning technique. Okay. And that is done by a pure anthropologist by training. The next one I'm going to introduce, this lady. We all know her. Florence Nightingale, okay, popularly known as the lady with the lamp. And she is the pioneer in the modern nursing and the healthcare. Did her best contribution in the Crimean War, which is during 1853 to 56. In fact, in the first year, there's a lots of death in the military hospitals. So British government decided to send her with her team to nurse in the hospital. And based on his contribution, she received the Royal Red Cross in 1883. Fine. This is all we know about her. What he found that over the years he stayed in the hospital, he collected data of the different hygienic factors. I don't know how it came to her mind, and the mortality rate. And of course, most of them data he collected from the military hospitals in the East. And then she established the dependence of the high mortality of the soldiers in the hospital, not because of wound, because of bad drainage, contaminated water, poor ventilation, and overcrowding. And that report actually compelled the bosses to rectify all these things in the hospitals and reduce the mortality rate from 40% to 2%. Okay. Now, all you know, the funding agency, the people who have the fund to do all these things, the policy makers, are not really convinced very easily. Okay. And she has to convince him by showing the data, and just a mere figures is not really enough to convince them, because that's not really convincing. So what she did, he invented what is called is a rose diagram, is a kind of polar chart to present this statistical data in the visual form. Okay, there's a complete innovation. There's one of the slides from the very old paper. Okay, and this is a circular one. Okay, if you can see, that's a circular chart. It started from the April 1854 and going around the year ends in the 1855. Okay, and All the data is visualized by a triangle or the wedge from the same common center, and the area of the part of the wedge gives the mortality rate in a particular region. Okay, and blue wedge, there's a area, represents the number of death which could be preventable. Okay, and that's dominating. Red is only the death from the wound, and black is the, what we know this term nowadays after the COVID period, is the comorbidity. Okay, because of other reasons. Okay, so this shows the majority of death could be prevented if we had those factors is noticed now. Okay, so a person who is not really trained in his academic year, the either statistics or machine learning anything, or schooling or the childhood, she learned history, classical literature, Latin language, and little bit of mathematics. Invented this kind of data representation, data visualization, and analyzed it and established the dependency of mortality rate with this usually unconsidered factors, bad drainage, poor ventilation, and etc. Okay, and because of that, this lady of the lamp was given or considered as a pioneering in the graphical representation of the data, number one in the statistical group, and she is the first female member of the Royal Statistical Society because of her contribution to statistics, and also the honorary member of the American Statistical Associations. Okay, so these are the people, not from the computer science, not from the statistics, not from so-called AI or machine learning. They have the first step towards the you applying machine learning techniques or AI techniques in the social science. Okay. In India, the founder of my institute, that's a Indian Social Institute, Prasanta Chandra Mohanavis. I surveyed all his contributions in the last 1 week and found these 3 papers. Okay, there are some other papers also. Okay, in 1921, he measured the length of the head and the breadth of the head, and analyzed the data to find out certain kind of constant ratio of the Anglo-Indian community in general. And the another paper is basically main structure of the Anglo-Indian community in the Kolkata. Okay. Being encouraged by that, he just ordered and procured from the Germany a special type of camera to measure the human features so that they can be categorized of the group, etc. So we see the person is, of course, by training is a statistician, but think of biometric. Now this is talking about the Aadhaar card, the face, and this is right in the 1933 itself. It could be a signature of a human being. Okay. So we are talking about the using the AI, concept of AI in the social science. In 1982, as Professor Chaudhary already mentioned, that from 1950 to 1990, the AI techniques or ML techniques are developing slowly. So 1982, it's almost at the young age. This Richard Janel, Professor Richard Janel, he is by training, he's a historian. Next, he shifted to computing department in the Imperial College London and working with the AI techniques on history, teaching, and research. Okay. And he himself developed a toy system using at that time is a very popular computer language that is used for the AI programming, the programmable logic or the prologue, and that could do that could do answer to questions of a certain form, if posed in the certain form. Okay, and in his seminal paper in 1982, he divided the people related with this social research with AI techniques in the three groups. One is a historian, basically who studies the human past based on all the primary or the secondary evidences, documents on a particular subject, and then write some historical account on that subject, okay, which can be used as a source of the information in future by other people. Student of history does the same thing, studies the human past, means the primary and secondary, but he examines or very carefully, thoroughly studies how to write a historical account from his teacher or the supervisor. Okay. On the other hand, the AI researchers actually studies the human mind and try to examine or understand the way people produce the historical accounts of a particular topic. Okay. Now, why is learning that? Why is studying that? Because his or her ultimate goal is to modeling this behavior. There is a how to generate this historical account, how to model that, and then how to encoding it to make a computer program so that the product of the system, output of the system will be indistinguishable whether it is generated by the machine or a live historian. Okay, this is his research. So this is basically what Professor Chaudhary has already described as a generative AI. Okay, given some information or the clue, it can generate a kind of historical documents. It's by the chat GPT also, he just answer and gives us. Okay. And at that time, Professor Richard Daniels used a prologue. It's a very simple, it's a very limited type of question answering system. Now it's a much more wider, much more efficient or effective system has been developed based on the large language model or generative adversarial network, etc. Okay. So basically, when this cooperation happens between the AI researcher and the historians, what each can contribute to others. Historians can contribute, they can offer their expertise on the domain knowledge. They can reconstruct the things and the wealth of examples, and of course, a healthy skepticism or the healthy debate to generate the accounts. On the other hand, artificial intelligence or the AI researchers can offer a rigorous approach to modeling, generating the distribution of data. Sir Chaudhary again and again emphasizing on that, from which we can really predict some kind of description of the things and analyze the structure of the model. Okay. So there's actually share the same objective. There's a producing an account that coheres with the observed reality that's already available in the documents, and they generate the prediction and the ultimate the explanation and the appropriate conclusion. Okay. So basically it goes hand in hand. So why we take the help of AI by the social scientist people? Because it may enable achieving goal in a much better way at various scale with small data, large data, even without any data. Okay. Though most of the machine learning technique or the AI techniques expect we have to have a large amount of data to train the system, but there are techniques both by the human being and by the machine, that it can be learned without, or it can predict even without a single data. Okay. For example, we also learned the, say, even the simple alphabets in the uh, childhood. This either A, B, C, the A for apple, B for airplane, A for ant, and so on, right? And every time you get a book, it's a different font, different size, different colors. But we ultimately made an abstract in our mind that's what actually the A is. There is no rule. We just learn through the examples, right? But if I take this specs and if I ask you, should I drop this from here? Right? Should I drop this? Everybody said no. Why? It will break. But have you seen anyone to drop this spec and broken it? No. Right? But there's a kind of predictive, even without the data. Even without data, your predictive knowledge says it cannot be there. You can say it will break. Another advantage of the AI techniques that it can work with natural forms. Okay? So this natural form is from the speech, from the visual information, from the printed or handwritten text as input, and output can also be generated in the desired form. Okay. I try to avoid the math so far. Okay, just a little one or two slides. Okay, just for very concise representation. What this machine learning framework does actually, it takes a set of inputs or measurements, okay, which is X, okay, and gives out the prediction or the conclusion of the inference as a Y. By a kind of transformation, the mapping we call the F. So, what this machine learning techniques does, it takes lots of this X. Okay, it takes lots of this X and Y, and with these examples, try to estimate that model F, this transformation function. Okay. So once you are happy with your transformation function or this model F is good enough to explain all these X's to predict the same Y given, you are confident that your transformation section is just like you are teaching your student over and over again till he can answer all the questions given in the exercise, right? Once you are happy that he has learned or she has learned, then he or she is ready for the examination. Okay, and in the examination, he or she will face an unknown question. But since his training about that kind of topic is good enough, is exhaustive, he can give the appropriate answer. This prediction is correct. Okay, that is what we understand, and that's all is the machine learning. Okay. Now the machine learning is got a little ahead, and the input is again this X at this time instance T, and also the whatever the output it has the system has predicted in the previously. Okay, just like you are typing in the Google Mail, Gmail, you will realize after some time the Google starts predicting or supplying the information, because by that time the system or the which is based on the machine learning, the artificial intelligence, it's what you are going to write, right? And it goes on, you're suggesting the words like this one. So based on the current input and the what is already predicted output previously, now next information coming up. Okay, And this is more or less a structured learning. And this structured learning is of speech, because it's a continuously with the time. Maybe the text sequence in the sentence, word after word, maybe matrix, maybe image, video, etc. And it has some examples. It can do the machine learning, machine translation. Okay, I just tell you one particular incident. Probably historians may know about the Professor Tapun Rai Chaudhary. Is a professor at the history department at Oxford University. He wrote a book and is almost a autobiography in Bengali, is called Bangal Nama. And there he just repented that he tried to learn Farsi language. Okay, and why? Because he wanted to research more rigorously in the middle age of in the Indian history period, so which is the Mughal Sultanate period, when Farsi was the official language. Okay, he learned it. He told us he learned a little bit, but could not master it. Okay, so many of the documents he just missed to get the proper information. Okay, so if he had a translator which could convert this Farsi to English or to Bengali, it would have been much helpful for him also. Okay, so this is useful. Okay, so sometimes we got some kind of speech information. It can be easily transcribed to written textual form. We call that transcription. Maybe a chatbot is a simple question answer session. We have many such examples already in our daily life. Okay, there are many such in the tools already available in the AI or the computer vision domain, which can transfer the style from one particular painting to another painting. So the image translation, it can be a simple bridge with the painting of the Van Gogh, and generates an image. If the Van Gogh were painted the scene of the bridge, okay, it's a kind of that, or given a set of sentence of the description, system can generate the image, and the other way also. Okay. So there are many such techniques already available, and social science people, though I told that they have started this area, but unfortunately over the time they have somehow lost the track and missed all the developments in the AI and not in a part of that. But they can easily pick up all these things and come back. Okay. For your information, one such example is, or losing track of very important thing is, we all know the Arthashastra written by Kautilya. But very few people know this Arthashastra was lost. Okay, it was not in use or not is read by any people for thousands of years. Almost probably after Harshavardhana, this text was lost. And it was, okay, yeah, it was almost in 1905, it was discovered in the Royal Library in the Mysore, okay, by Rudrapatna Samashastri, and he found out somehow and is converted the translated the 1909 in Sanskrit and then in English in 1905. Okay, so this one of the important thing is any research is searching out the old material, okay, which is called the document retrieval, and these documents are retrieved from the database which may be unstructured, may be distributed over the various sources. And this kind of retrieval is very easy if it's in the textual form, because all the documents can be categorized or labeled with a set of keywords. But there are texts which are not really in the textual form. Maybe the scanned images of the pages of the old manuscript, palm leaf manuscripts, and so on. Okay, they could not be similar. So in those cases, what we do, we kind of word spotting techniques and other things. Okay, some of the documents which are very poor quality, old documents, it's almost more than 100 years old later, we got from the archive of the PCM Museum and Archives. And it is a physical damage, back impression, and so on. But the AI techniques can improve that one to make it very clear, which is much better legible than so on. Some of the documents cannot be really converted to word spotting like this one. This document we got from the scanned images of the Asiatic Society Bengal. And if we want to find out some keywords present in this page and many other pages, what I do, we don't have the OCR version. And it's very difficult to develop a OCR for this kind of script and the pages. So what you do is just take the written shape of the particular word and try to search it out. And from there you can see the yellow boxes which can basically find out this particular word, this gopi. Another important applications that many of the old documents can maybe torn or fragmented, maybe because of physical, because of being old, or it's like intentionally. One such example is just at the end of the Second World War, Nazi government tried to tear off many of the documents, and later there is a research project for the reconstruct the record of Nazi culture plunder. Okay, they have to try to put it in the assembling all the documents. Okay, it is usually started with the manual. Is a mammoth task. Is almost impossible. So we apply some kind of machine learning techniques to put them together. It's a little bit of different of solving the jigsaw puzzle, because jigsaw puzzles are exact, no missing pieces. All pieces are fitting one another perfectly. But here may be some missing part, something also. And this kind of technique can be applied somewhere else also. Okay. Now another thing is, probably in the afternoon, the Professor Indu will talk about the more in the reconstructing the things. And you know the historical documents has many a times of the missing informations. And you have to put all the filling up these gaps just based on the other secondary information, and you have to validate it from the other sources also, right? And integrating all this information from the various sources, we need to validate with the authentic documents at the same time. And this reconstruction may be done in various modes, maybe text, maybe image, maybe other things. All the Professor Chaudhary had shown some of the results on the 3D in painting and 3D to reconstructing the objects, the missing parts. I'm not going to. I just try to mention one. The Samrat Ashoka, he is also lost for centuries. Okay, in mid-17, and after that, British explorers, British adventurers, moving around and found out some of the pillars here and there, even in the Firoz Kotla, and some stone edicts, and they put together all these informations, and finally built up and found this particular full story of the Samrat Ashoka, known as Pure Darshi. Okay, and the whole account of this, all these experiments is given by this particular book, uh, Ashoka, the Lost India's Emperor, written by Charles Allen. You can read it. One such example of reconstructing this, isn't it? On the left, there's a ceiling of a particular temple, whose some missing parts, is a flakes are moved out because of old age, and these are some computer vision technique can put together and find it. Okay. Now, most importantly, whether you like or not, you have to go for the machine learning and the AI techniques. Okay? Because nowadays, on the internet, on the different resources, there's a lots of fake documents are there. And you have to find out is it true or fake. I'm giving you two examples. In 1983, journalist George Heidman claimed that he has discovered 60 small notebooks of Adolf Hitler, is covering his life from 1932, end of his life, okay, till his death. Okay, so that contains all his the things, starting with the rise in the power, Holocaust, everything, war planning, everything, right? But with the forensic research, ultimately turned out in May 1983 that everything is a hoax. Okay, but by that time, German newspaper Stern has already paid a lots of money to that journalist Heidman, and he become rich. So this kind of hoax you have to really face, whether it's a historically true or not. Another interesting example is 1794. William Henry Ireland is a teenage boy, age 17. He claimed that he has found out some of the written documents of William Shakespeare. That includes the deed of selling some land, writing letter to Elizabeth I, and these and that, including two plays, Henry II and the Partisan and the Ravana. And later so you just understand, overnight he became a celebrity. But in 1796, it was found everything is actually fraud, and the Ireland admitted his guilt. Okay. So nowadays, these kind of hoax are coming as the larger scale because we have the tool which can generate the document. Okay, and historians has to find out whether it's really true or fake. And here is some examples of faces of those people who never existed. On the left, top left, you see this result in 2014, comes down at the bottom right in 2021. It's almost like a natural photograph. Okay. Now, if someone like this one, some image of like this one is put on your side and take a picture, and some of your family friends ask, who is this one? Why is he related to you? How is he related to you? We are in the problem. Okay? You have to really explain from where this man or the girl came, right? Okay. Here's another picture. Great Trinity or the famous Trinity test. Einstein is going away with cycling, but this is a fake picture. Einstein was not there. Only historians know that Einstein was not there. It's a fake picture. And here are two other pictures. Right? On the left of the Stalin, there's a person. So you immediately understand this person must be a very important one, very the high level at the Soviet Communist Party or the Soviet administration. But in the picture on the right, he's missing. Okay? So which one is correct? Whether the man existed or not. For your information, the man existed, but somehow it is removed from the photograph. Okay. So there are too many fake documents are on the internet. Students are nowadays don't go to the library. They're all looking to the Google and find out all the documents. And majority of them might be the fake. Who is going to authenticate them is the social scientist. Okay. With that, there is a response to you. I conclude by we know the AI techniques are already in use in the social sciences, but how is the power of physics level of the AI is very important. But we must be very careful so that AI should not dominate the researcher. Okay. Already there's a question and session. Someone asked about the unbiasedness or the kind of inclination of the AI models based on the data it is used to train that model. So we have to take care of that all these things. What Professor Chaudhary is already the trustworthy AI model is very, very important, and that should be justified or validated by the users from the actual domain. Okay. With that, I thank you all of you for your attention, and thank you.
We can have one or two questions.
Yes.
Dheeraj.
Good afternoon, and thank you for giving me this opportunity. Sir, we understand this AI is going to bring a revolution all over the world. And so far, we are understanding the AI is going to work for social sciences also. Because AI is going to make predictions which will be based on data, and data should be accurate. My question is that in some of the field of social sciences, where the data is not accessible or not updated, so how is it going to help the social sciences which are not updated? How will you look into that? Thank you.
Okay. At some stage of development of AI or the machine learning techniques, yes, we rely on the data heavily. But nowadays, as Professor Chaudhary also mentioned, and I also told, that there are techniques with a little bit of data. We call the few shot learning, single shot learning, zero shot learning. Okay? And those are techniques available where data are not sufficient, not adequate. Okay? We can use that kind of technique. And there are techniques also which not only relies on the data, but also based on the logic or the predictive model from the system. Another thing we forgot to mention, we call the transfer learning. Okay. I just give an example. You are quite habituated using the metro in the Delhi, maybe in the Mumbai. Okay. You know what to do there. So buy the ticket, go through the I put the things, and I will the metro and how to. Well, if you go to Paris, if you go to New York, there are also metro, right? There are a little bit of different rules also there, different kind of systems. Okay, can you use that? Right, very easily, right? You you already know how to use the metro. You just little bit fine tune that one. Okay, it's called the transfer learning. Yeah, so you know this, how to use the historical data for predicting things in certain period. Okay, from that model, you can fine tune your little bit of data you know for some other period. Okay? And that will equally reliably generate the similar kind of reliable output from that data. Okay? That's the thing. Okay? That's what you would call the transfer learning of the person. Okay?
Professor Chandra, thanks. I have a question which relates to your presentation and also Professor Chaudhary's presentation. There are two things that we are hearing. One is the use of AI in social science, and the second is the way social scientists can contribute to development of AI, especially as Professor Chaudhary said, in the field of wisdom. Now, social scientists and humanities people know that wisdoms are competing fields. They are competing wisdoms dependent on power relationship. Now, there could be two scenarios. One dominant wisdom could be inserted in the AI by the developers and those who control. Then it's possible that those who differ with that dominant wisdom would become victim of that kind of AI system and scenario. So, is there a thought or discussion going on how to deal with this situation of competing wisdoms and the power relations that would influence the AI scenario and situation? And as a social scientist, even if we contribute to it, we may not have control on which the dominant wisdom would become the part of the AI system. So that's my one question. I want your comment on that, because that will help us to think about our contribution to development of AI. The second is related to international inequality. We are fully aware that how the previous generation of mechanization and machine development created international inequality and international division of labor. Is this new phase of machine development, technological development, going to replicate the same previous experience of international inequality, or are we placed in a different situation given the advantage that India, a country like India, have in field of software industry? Thanks.
Difficult question. So I have to take some water to digest first. Okay. The first question related to more to policy decision. Okay. So how far we will allow AI to encroach in the field of the social scientific wisdom, and how far social scientist domain knowledge is used in the AI or the advancement of AI. Okay. This is not the right forum. Also. I can tell anything, and you can listen to it and go back. It's not so. In fact, this Vice Chancellor ma'am, the Inaugural talk about the threat of these and these and these and these and we have to mutually work together, etc. Everything is just I'm telling you that, reminding us a small old story, and I skip to next question. Okay. Do you know in the movie of the Spartacus? She talked about the Terminator. I'm talking about the Spartacus. Know the Spartacus? All the slaves, the gladiators, they revolted. Okay? Against the elites of Romans. And basically, they had the muscle power, they had all the officers, they could fight. And initially, they owned all the battles they are going to. And you know finally what happened. Right? So, if only the muscle power, only the force, or only this is the deciding factor, probably some wrestler would have been our prime minister. Okay, it's happened in the prehistoric time, but not now. Okay, there are ways out. Future will tell us whether we can really overcome this kind of problem or not. I'm not here to. Second question I forgot by this thing. Okay, so the second just one. What is the second question? Related to?
On international inequality.
Oh, inequality. Okay. Inequality. Again, it's another policy decision question. We all have gone through the COVID period. Okay? And this COVID period has transferred our education methodology from offline to online overnight, right? And immediately a kind of inequality created. Those who have the facilities to access the online teaching and those who have not. Okay? This online or this AI has the advantage or making the things at the even playing down or the equality. The AI or the digital space has made us or gave us the opportunity to listen to professor at the MIT, professor at the Harvard, professor at the Oxford, sitting here. Okay, there's a one kind of equality that has been brought. Okay. One kind of equality has been brought by the Google or the Wikipedia or thing, the similar documents, similar source of knowledge is available to all of us. Okay. So there's a kind of equality. The ChatGPT, if I write the question, the answer he gives me, a poor village boy, if he writes the same ChatGPT question, he will get the same answer. The kind of equality. But the inequality is another level. The system I have to type down the question, prompting the question, having the ChatGPT connection on my system may not be available to other people. That's the inequality, the advantage I get. So this is the kind of inequality. Inequality not in the single particular factor. It has different facets, different factors. Equality at what level? That's a major question. Equality in what types of resources, what types of facilities? That's the question. In some cases, I will bring the equality. In some cases, it's not. The kind of system Google can use, Microsoft can use to run an experiment in the premier institute in India, IIT Delhi, IIT Bombay, IISc, ISI, don't have these kind of system. That's inequality. Okay? Thank you.
I don't think any questions are there. Thank you, sir. Your talk has undoubtedly enhanced the success of this workshop and further cemented our commitment to exploring the exciting intersection between artificial intelligence, social sciences, and humanities. May I request our Honorable Vice Chancellor to please felicitate Professor Chanda. Thank you. Thank you, ma'am. Thank you, sir. After our engaging and thought-provoking sessions, let's take a well-deserved break to refuel, relax, and continue our discussion. May I invite you for lunch, and I request you to please reassemble at 1:45 for the third session. Thank you.
Faculty, colleagues, and students, and thank you for joining us for this post-lunch session, which I'm sure would be as appetizing as our taste buds were just before lunch. So we've already had 2 exciting sessions this morning, and now we are about to embark on a journey that explores the intersection of two incredibly dynamic worlds, AI and social sciences. Our theme for today's panel discussion is AI and social sciences, exploring interdisciplinary frontiers in the digital age. In an era characterized by rapid technological advancements, the interplay between AI and social sciences has become a compelling frontier for exploration. We are here to delve into this exciting intersection, and we have curated a lineup of distinguished panelists this afternoon. For the next 2 hours, we'll dive into topics that are not only fascinating but also deeply impactful. We'll explore the role of AI in healthcare, its influence on public policy, its interaction with the realms of law and justice, the alignment of AI with human values, and its role in heritage preservation. These are not just abstract concepts, but pivotal discussions that have a tangible impact on our lives, our society, and our future. Now, let me introduce you our illustrious panelists who are experts in their respective domains. So, I'm going to go alphabetically. I start with Professor Ashok Chaudhary from the Institute of Liver and Biliary Sciences, New Delhi. He is a renowned medical professional with a rich educational background, holding MBBS and MD degrees, along with a DM in hepatology. His expertise encompasses liver transplant, artificial intelligence, innovation, product development, HCC, and liver failure. He is not only an accomplished academic editor for renowned journals, but also plays pivotal roles in significant research studies. Dr. Chaudhary's dedication to liver research has earned him several prestigious awards. Today, Professor Chaudhary shall unravel the necessity and dependency of AI in healthcare during the course of discussion this afternoon. May I please request Dr. Jyotirmoy Bhattacharya, who's the member of our AI committee as well as Dean AES, to welcome Professor Ashok Chaudhary. Our second panelist for today is Dr. Dvipobhoti Brahma, joining us from the School of AI and Data Science at IIT Jodhpur. She holds a PhD in Applied Economics from Western Michigan University. Her specialization lies in applied machine learning, econometric techniques, and development and health economics. Dr. Brahma's research focuses on maternal and child health outcomes, child mortality and morbidity, malnutrition, immunization, and health insurance. She leverages machine learning and AI to enhance the targeting of public policy. And in the course of today's discussion, she will shed light on the intricate relationship between AI and public policy. We welcome you, ma'am. Our third panelist is Professor Lawrence Liang from the School of Law, Governance and Citizenship at our own university. Professor Liang is a recipient of the Infosys Prize for Social Sciences in 2017. His extensive writings on the politics of intellectual property have left an indelible mark in his field. He has been a distinguished educator at renowned institutions like Yale, Columbia, and the University of Michigan. The topic of today's presentation is From Code to Courtroom, AI Interface with Law and Justice. We welcome you. Our fourth panelist is Professor Ruchika Malhotra, a distinguished academic and the head of the Department of Software Engineering at DTU. She has an impressive educational background with master's and doctorate degrees in software engineering from GGSIPU. She has authored several books and contributed significantly to software testing, software quality improvement, statistical and adaptive prediction models, and software metrics with over 200 research papers. Her dedication to research is further exemplified by several accomplishments such as the Raman Fellowship for Postdoc Research at IUPUI USA and her commendable research awards from DTU for 4 consecutive years. She's been recognized among the world's top 2% scientists in AI and image processing by Stanford University and has also received the IBM Faculty Award. Today, Professor Ruchika will talk about AI and predictive analytics. We welcome you, ma'am. Our fifth panelist is Professor S. Indu, with a BTech and MTech in Electrical Engineering from the University of Kerala and a PhD in Visual Sensor Networks from the University of Delhi. Professor Indu is a distinguished scholar. Since 1999, she has been a valuable member of the ECE department at DTU, where she is currently a senior professor and also the Dean Students Welfare. Her research focuses on computer vision, sensor networks, and image processing, resulting in 2 published books, numerous chapters and publications in prestigious international journals and conferences. And she has also led many sponsored projects from organizations like the Naval Research Board and the DST. Her outstanding contributions have garnered her the Commendable Researcher Award from DTU for 5 consecutive years, as well as recognition from IEEE USA and IEEE Delhi section, receiving the Best Branch Counselor and Outstanding Branch Counselor Awards. We welcome you, ma'am. So Professor Indu has been doing interesting work on role of AI in heritage restoration and preservation, and we are excited to hear about it from her today. Our fifth panelist is Professor Vasudha Bhatnagar. Our final panelist is Professor Vasudha Bhatnagar, currently a senior professor in the Department of Computer Science at the University of Delhi. She completed her bachelor's degree in statistics and master's degree in computer applications from the University of Delhi and doctoral studies from JMI. Professor Bhatnagar has guided several doctoral students in the areas of data mining, machine learning, network science, and text analytics, and has widely published in these areas. Today, Professor Bhatnagar will guide us in aligning AI with human values. We welcome you, ma'am. So let me just share the format of the session. Each of our esteemed panelists will have approximately 10 to 15 minutes to share their valuable insights on their respective topics. They will provide us with a deep dive into the subject matter, and I'm sure that all of us will find their expertise both enlightening and thought-provoking. Then we will open the floor for a moderated discussion, expertly guided by Professor Lawrence Liang. With his keen insights into the convergence of law, culture, and technology, Professor Liang is the perfect moderator to lead us through this intellectual exploration. So once again, thank you for being a part of this exciting discussion. And we can start. So can I request all our panelists to be seated in the theater, and so that we can all view the presentation, and we can start with Professor Ashok Chaudhary. And we'll have a student volunteer here who will just signal us at around 12-13 minutes so that we all keep the time. Thank you.
I think, as rightly discussed, and also BC ma'am also, they all are apprehensive that how AI is going to come into social science. Same also for your health also. How you can rely on a machine for your health. So in following few minutes, because I am a proponent of AI in health, so I'll go. So I think everybody know that artificial intelligence come after this fellow. The natural intelligence has taken birth, but now they are not coming again. Though I think everybody know this Ramanujam. So now AI now makes everyone enabled not to be Ramanujam, but to some extent can go to that level. You can do good work in expert way, and how justified will come in few slides. So basically, the AI is a process of learning that a child to adult, and that experience gained through it goes into actions. This action may be wrong, this may be right, and hopefully it will gradually over the time it will come up to something. I think this I'm going to just we are not copying. So before going to the related, because being in medical field, everyone think that what is health? Is it absence of disease? It's no. So it is having a very good components here. You can see this is called now the wellness. You can see you need to be emotionally, physically, career wise, social, cultural, environment, finance, spiritual. You have to be always in balanced all way. So if you think that way to go for, then concept of having a holistic approach is needed. So in that case, the social science, social health is also integral part, where we need it to be an economically stability. We need to have a balanced one with our environment, in our healthcare and in education. You just see health is coming only pure health coming to the one part in this fifth dimension of the societal health, you can say. So why we need healthcare need of India? We just see, need in India is such a nation. Whenever discuss, there will be need is beyond comparison. So we need, you see, 70% need mental disorders. Patients started treating, 70% going dropouts, 70% having some problems at some part time. So this is going on. And now we are struggling with the problems, obesity. And this is, you can see the graph, how we are going on. Diabetes, India is the capital. And alcohol consumption, we are now leading to the world. And because of this, you see, the most important for us is our obese children's. And we know the tobacco use. And see, alcohol, if you are not taking alcohol, but for you quota is 5 liters, because your someone friend is taking alcohol, so your quota is 5 liters. So for every individual taking 5.2 liters of alcohol per year, even also you are not alcoholic. Okay. And to address this, there is a huge supply demand mismatch. We need this curve that our primary should be robust, secondary should be adequate, tertiary should be minimal. But here the health system is ours now. We focus more on the tertiary urban centers, whereas the rural is very less affected. This is the huge burden in this. And next important, you can see here, every accident takes 1 minute, one accident is happening, and one death is happening every 4 minutes. So this is so much of burden, how you are going to address by this manually or physically. So here you see, this is very interesting that how public health, social innovation and community participations, you have to make all across, including public health institution, health delivery system. There is one part is a hospital, private industries, NGOs, here we are seeing universities and government. We all need to sit together, and how we can think of that AI can go into good way, because obviously something to be done and it's collectively to be done. That is what we need. And this is see, and why you need everywhere you see the commercial interest. And you can see in health is the most promising field in the country, you can say, rapidly rising. And the urban health is much, rural health is more important rather than the rural, because India lies in the rural. If you think that AI related social health can focus the rural health, it's going to have huge expert. You just see telehealth, I think everyone is aware of. I think COVID has given example that telehealth or AI domain is going to address the issues we have discussed. Think of distance learning. I think now most of courses are going on this way. Training the rural areas, you can do health AI related facilities. Most important, you can see the ASA workers or nursing at the remote levels. You can enable them from here to cover this huge gap of health burdens in the country. And you just see now, this is the way we should think of educated, trained and well connected through the platforms to provide service, to handle the burden at the remote level. This can be done by some part with health. You just see now AI has come into multitude actions, from personalized healthcare plan to cancer drugs diagnosis, drug development, rare disease, virtual nursing, fraud detections, cyber security, gene editing, even to the guiding your surgery also. And overall, and everybody, I think nearly 60% are using this health monitoring and wearables right now. So this is how the application of AI is expanding every day we are definitely involved and getting care. Just I want to say how AI is helping. This is a acute patient journey mapping. AI can help a patient enters from here, how his data collected, how his symptoms are going on, how he's getting triaging, how he get admitted, he get treated, then his discharge, his finance billing, everything goes in single go and all can be kept through this. And next important, I told you the chronic health. We know diabetes, alcohol, obesity are the measures. You just see, if you are using AI for various ways I've discussed, you can able to, this is a projected that you can help in controlling the complications of diabetes 66%, heart disease by two-third, cancer by two-third, and see, you can get a huge benefit if you think that this can be usable. And obviously we discuss the telemedicines. Being a person in liver, I just want to say that liver related liver disease, AI has also take a help big way. Fatty liver, I think I'll just show, everyone will be frightened here. You see what in our India. So fatty liver is 9 to 32%. That means every third person here sitting is having fatty liver. As a simple way, I can tell fatty liver is now the most common cause of liver problem across the India. Previously, people thought that alcohol is a problem. No, it is now non-alcoholic fatty liver. And simply, I can say those tummy is out from the shirt or t-shirt, they are having maximum maybe diabetes, fatty liver. If you have diabetes, you are a family history, then you will maybe having this. And this is a silent bomb which is going to explode. And how we can do? So here, see, this is a simple data where we can go for this test. Simply AI-based models with accuracy of close to 90%. Help can you detect and how can prevent. So this is coming a simple cheap how you help. Then second, liver and brain. Most important that when there is brain problems related to liver, you are not taking decisions good. If you go for driving, you are not able to take proper way. So now things has come up. I think everybody know this Siri assistants, Amazon Alexa, they all now giving a prediction model that you are having some problems. They can dictate from your voice that you should not start driving or you should not take a major decisions where you need a high mental skill. Suppose you are going on the rough road, very narrow path, so try to avoid. So this is how you can help peoples in this. I think liver failure related, I think it is my most of is my work, I don't want to go for. So we are able to develop that how this people is going to develop problems, how they can going to help, how they can going to have a problems related to this, whether they can catch infections. We can able to tell this with a prediction tool, but we need to develop much further. If you think of infections, I know everybody's no sepsis, and this is also now we are getting help this way, but we need to go ahead. If you think of drugs, I can say that every day 1 in 10 people comes to us with a liver injury because of drugs. That drugs may be antibiotics, that may be painkillers, that may be some medications, complementary medications. We sell dietary supplements, and how we can prevent it. So this is we can do by simply go for the some test panels that can help you to guide that you should not suffer from this. So now one app is called safe drug app where you can think that you have to take these drugs, how can go for, you know, liver, to know the liver problems we go for some invasive procedures, and you have to see the surgery and you have to put a cannula. But now this is helps to us, but do a CT scan, you can get your value that this much is there, and this is accuracy close to 90% you get. Then cancer is a big menace where also we are able to come through how we can go for, and you can see the cancers in India is newly rising where we can detect, we can prevent, and everybody aware of this mammogram has come by the AI domain where simply by a mobile app pictures you can with sensitivity you can able to predict. So this is how the social and societal, these are two along with health can help. And this is simply important of medical AI diagnosis. This is a young student who mentored by me, he's doing a startup somewhere, but I help him. Just see a simple machine, you don't need any blood, you put your finger like a pulse ox, you will get all 5 parameters: liver, kidney, oxygen, hemoglobin and sugar also. This is how these are going to reach the masses. If you take this machine with a little bit charge, you will go to remote village, takes 1,000 people's data, come over and just download, you can analyze and can tell them its values, how we can go. But now important is we are become gradually dependent on, you just see administrative workflow becomes easier, virtual nursing assistance is coming up, we are depending, we are getting less error, so we are depending, surgery can be helped late, and frauds particularly related to billings, other things can be helped out. And it has improved the user experience, how they are getting benefits we can get through this. and it can help as we discussed for the diagnostic modalities, and obviously we discuss about the healthcare monitors. I think my next speaker will come on women child health addiction drive. Now they are putting trackers so that if your child is more prone to go for, you can track them where they are going, which groups are going on. This is how mental support. Every one third person in this country is suffering so mental illness. You can get guidance through this. Cardiac health now comes to wearable monitors to know. So cancer surveillance. These are all coming big way, and this is we need to know how to go for. And health industry definitely is a big book I not want to show, but India has a huge scope. If you think of coming on, particularly healthcare is still unexplored, and we need to think of how to go for. But important is the whole critics, why AI in healthcare still not foolproof, and why fear. Because accountability, who will be accountable for the decisions, how ethics will be guided. If legal issues, the court will issue someone in the name of whom. And research is not till now a collaborative. This is the biggest problem, that engineers think that way, doctor think that way. So there is no marriage between doctor and engineer, mentally not physically. To get a good decision, how can go up, and there is a fear of insecurity for the policy data and management. So now recently the guideline has come that how ethically AI in healthcare can be guarded. So first important is respect for the person, that is autonomy. The data should be anonymized. Do good. The data should give maximum benefit, and the benefit of doubt should go to the patient, not to the science. And do no harm. That is most important. And next important is that it should be a responsible AI, and it's been controlled. And this guideline has been recently decision this year by ICMR. So I just want to say that it is innovative, it is futuristic. Now you can see lot of startups are coming up with healthcare in AI big way. But important is how to address this in the bigger way with futuristic ways. So if you think of here, I think a lot of people say they are social, because I am little bit into preventive health. So I do work on this fatty liver. I have now going to have AI model for detecting fatty livers, and we are also doing for the liver cancer. Diabetes is a big risk, how we can think of. School health, I think a lot of students are here, faculties are interested, and how we can think that way, where AI can be a responsible way, guarded AI with ethics to help us, because it should be a necessity. At the same time, dependency should be calculated with risk. Thank you.
Good afternoon, everyone. A big thanks to the organizers, particularly Jyotirmoy, for inviting me. So I'll talk about how artificial intelligence and machine learning is being incorporated in public policy. Now, this is actually a very large space, okay? And my talk, I'm going to talk about 3 different distinct ways in which artificial intelligence is being incorporated in policy making, and talk about specific successful examples in which it has been incorporated. So, from the morning, we've heard people talk about how artificial intelligence is the driving force behind most innovations today. And so, naturally, you might be thinking, why should policy making be far behind? So, artificial intelligence can be used in various stages of public policy. Okay. The first, so I'll talk about 3 broad ways. The first is just using it to get more data. So for those in the audience who are already from a public policy background, you know that it is very, very embedded in data. Okay? But artificial intelligence is being used to augment our existing sources of data. Okay? And so I'll give you a few examples. The other is using artificial intelligence in prescribing policies. And the last is using artificial intelligence to analyze and evaluate policies. So out of the last 2, the first, the policy prescription, is more of an ex ante, and policy analysis and evaluation is more of an ex post work. Okay? So we know that the robust policy requires good data. Okay? And other than artificial intelligence and machine learning, the other buzzword that goes hand in hand is big data. Now that itself is a vast literature, and there are many different kinds of big data. But where it is being incorporated in policy making, okay, is we no longer have to rely on traditional sources of data to allow us to make policy. Okay, so one of the examples that's been very popular recently is using night lights data to construct small area estimates of poverty or economic growth. Okay. So traditionally, we had to rely on large household surveys or census to look at economic evaluation, and they always came at a much higher level. So states, districts, and so on rely on non-traditional sources of data. Using that to augment can allow us to get more granular estimates of policy making, granular estimates of economic activity. Social media data. So, I think many of us here in the audience have gone to rant on social media if you've had a bad experience with a particular brand, and that reveals your attitude towards the brand or a product. So we can augment our policy making using customers' sentiments that they reveal by going on social media on their accounts and talking about it. The third example, and these are three broad examples and there are many more, is using natural language processing to uncover tones and perceptions that people feel about different aspects. Okay, so we can uncover the tone that people feel about, in macroeconomic policy making, the Monetary Policy Committee, each member has a different perception about, say, inflation. And so we can use minutes of these meetings to look at what each of these individual members feel about the inflation target of a country. So next, I'll talk about policy prescription. And so here the question that artificial intelligence helps us answer is something a little bit more specific. So we can move from asking, what should a policy be, to who should it be for, and where should we implement it. So we can go down to a more granular level of policy making. And historically, in India and in other countries also, policy making has had this top-down approach. But artificial intelligence and machine learning gives us the tools to have a more granular approach towards policy making. So an example of how it has been used is in allocating inspectors. So, any policy requires monitoring and evaluation. So if we are to set standards of care for hospitals, or in this case, the examples that I have were for looking at buildings in cities and making sure that the construction is up to code. Okay. In order to understand if buildings are being made up to code, you need an inspector to go and look at it. Now, these inspectors who are qualified to do this work are limited in number, but there are so many buildings. So this becomes an allocation problem. And you can use artificial intelligence to predict risks and allocate inspectors to those places which are most at risk of violating the norms. So similar work has been done across the globe in New York City, in Boston, to allocate health inspectors to restaurants to look at who is likely to flout the rules. It has been used to detect tax evasion. Okay. So we can combine large administrative data to look at tax evasion cases. Okay. Recently, and during the time of COVID, Google Trends data, which we all, inadvertently give to Google every time we search for something online. Your search patterns tell us what people are doing in a particular area. What is the most common thing that they're looking for? And so it has been found that just before COVID, most people were looking for very similar symptoms. They were looking for loss of smell. They were looking for, they were Googling watery eyes. So search trends from a particular area can help us predict, onset of flus, onset of pandemics. In economics, it has been used to understand if employment is picking up in a particular area. So for example, before people start a new job, they often Google, what should I wear to work? Formals, where do I buy formals around me? We can use that to understand if employment is picking up, or if people are losing jobs, the first thing they do is search for another job. So your Google trend results tell us if there is unemployment in a given area. Okay. So we can go beyond answering, who, where, and look at even more granular work. So some work has been done in Malawi, where you can use artificial intelligence and machine learning to predict famines. Okay. So here the policy question that artificial intelligence can help us answer is where. So if you want to know where is a famine likely to break out, you can use these tools along with data to get more granular estimates of famine. School dropouts, which is a huge problem not just in the US but also in India. It can help us answer who is at risk of dropping out. Some work has been done in India on this, where artificial intelligence can be used to predict which newborn is at risk of dying within the first month or year of birth. So how does this help? These tools can be used to create screening criteria. Okay, so we can start screening for adverse outcomes early on and give better care to those that our systems tell us who are at risk. So examples such as domestic violence. Okay, so artificial intelligence and machine learning in combination with large-scale data has been used to predict hotspots for domestic violence. What it does is allow people to, the first responders, when you call 911, it allows them to screen and prioritize calls. Or if you want to send a patrol police car, it tells you which locality to send cars to. Social security, which is a big problem in the US. We have, similar issues in India as well, where if you're giving, long-term income support to somebody or some family, artificial intelligence can help us understand who is likely to need it for a long time, how long they're going to need it, and that in turn helps us budget accordingly. So if you can tell families who are unlikely to be able to get off income support, you can budget how much support you're going to need in the next financial year. So all of these go into policy prescription, which means ex ante, while we are in the process of making policy, we can make it to start with at a more granular level. We don't have to have the same policy throughout the country. So India is a vast country. There's a lot of heterogeneity. Some of our districts are larger than some countries in the world. But our policy making is still at a very broad-based catch-all level. So artificial intelligence can help us hone this and make this more granular. And on those lines, I hope there are some behavioral scientists or cognitive scientists in the audience. Using machines, we can incorporate behavioral insights and make policy making even more granular by using personalized insights. So an example of this that was tried out is, most of your faculty, you work with students, you know that they will do everything in the last minute, just before the deadline. Now what happens as a result is, very often students miss the deadline to file things, for example, their application for financial aid. So you can personalize email reminders to students using artificial intelligence to figure out what works best for which student and what timing should you send that email to make sure that student actually clicks and fills out their financial application in time. So it allows us to not have this broad, one-size-fits-all solution to policy, but you can cater it, you can tweak it, you can personalize it, and remember, it's a machine that's doing it. So it's not the instructor or it's not human, it's not tedious. You can tweak it to make sure that it works best for every individual. On that line, there has been work to improve charitable giving. So when you want to incite people to donate to a good cause, you can use behavioral insights to find out what works as a good nudge, as a good push to make people donate to worthy causes. The other way in which we can use artificial intelligence in policy prescription is to choose among possible policies. So Professor Shantanu Chaudhary spoke in the morning about randomized control trials that are being used in economics. And so one very big issue in developing countries is the fact that infants, families drop out of the vaccination schedule. So there is still we don't have 100% coverage of essential childhood vaccines. And so in order to address this, several things have been tried. Okay, so there have been issues where there have been experiments where we've tried to send SMS reminders. There have been experiments where we have tried to, give that information to a village sarpanch and see if he spreads the news. There's information that we can give to community healthcare workers. And so many different policies have been implemented. Many different small experiments have been done. So artificial intelligence can help us combine all of these, consider all of their combinations, and choose which one out of these is the most effective, in the sense which one leads to the highest gain in number of infants who get vaccinated. And in addition to that, which one is the most cost effective? So most gain per rupee that the government spends on this. So, I'll talk about policy analysis, which is the ex post, the last part of this. So traditionally, policy analysis is the field that most social scientists work in. And we've made a lot of advances in this field. So not just economics, sociology, political science work in this. And traditionally, we've looked at policy analysis as looking at what is the average effect in a given population of a particular policy. But using artificial intelligence, you can go beyond this. You can look at, what is the differential impact across different groups of people. So one example of this was the differential impact of the number of years of life lost due to air pollution. And that's not going to be the same across the population. It's going to be different for someone who's young. It's going to be different for someone who's old. Artificial intelligence combined with randomized control trials has been able to uncover that there's a very specific group of individuals on whom a summer employment program works. So this was part of an experiment on inner city Chicago, where if you know a little bit, you know that it's a very poor socioeconomic background. There's a lot of crime. Young boys and girls get trapped into a life of crime very early. And there are a lot of interventions that happen that try to prevent them from going into a path of crime and give them something fruitful to work on. But for a long time, none of these interventions worked very well. So when we evaluated them at the end of it, we found that it doesn't really have an effect. But using artificial intelligence and machine learning, it was uncovered that it does have an effect on a very small subgroup of people with very specific characteristics. Which means that this is not a policy that you should be rolling out to everybody. You should be targeting it to those people on whom it works best. Similarly, artificial intelligence has been used to decide or figure out what is the optimal time to give a phone call to pregnant women in rural areas to remind them to go get their health checkup on time. Or targeting farmers in rural areas to give them information on government subsidies. Okay. So one way of looking at this is whenever we get a call, so many of us get these spam calls during different hours of the day, and we listen to like 30 seconds of it and we disconnect. Okay. Most of those are spam calls, so you really don't want to listen to it. But what if a pregnant woman got this call when she was very busy during the day, but it actually has useful information? It'll tell her where to go if she starts experiencing complications. So as policymakers, we need to figure out what is the right time to give her this phone call when she has the mental space to actually listen. And artificial intelligence can help us, through repeated experiments, figure this out. Similarly, it can help us figure out what is the right time to call farmers so that they listen to the information that the government has about fertilizer subsidies for them. So I hope I've been able to give you some specific cases where artificial intelligence can help in policy making. This is a big field, and it's only getting started. And the use of artificial intelligence in policy making is bigger than just artificial intelligence and policy making. Together, it can probably revolutionize the way we think about policy and think about affecting people's lives. So that is all from me. Thank you.
Good afternoon. This session, in a way, typifies one of the key dilemmas of the human-machine divide. ChatGPT doesn't really care if it's a pre-lunch or a post-lunch session. But to be truly human is to struggle to be alert in the post-lunch session. So, you know, my talk today is called From Code to the Courtroom. And I have to credit Nidhi for giving me this title. She just suggested it when we were having a chat about what it should be called, proving in many ways that sometimes it's much nicer to just have a chat with your colleague than to even have ChatGPT. But I want to begin today with two images that I want to offer you of judicial decision making. The first one comes from a week ago when the Supreme Court, striking down a High Court judgment that had sentenced someone to death, had said that judges should not act like robots when they're implementing the law. And I'll come back to this. The second one is an image which is very common to many lawyers, which is the sheer unpredictability very often of judicial decisions. You have the same set of facts, you have the same set of principles, and the judge arrives at completely different conclusions in very different cases. To the point that in one of the high courts, for one of the judges where this was a persistent kind of a problem, lawyers just couldn't figure out how to, actually get how the judge thinks. And they started observing very carefully, and they found that actually the one thing that seemed to give them a clue was this judge was very fond of turning his ring while hearing arguments. And if the ring came up on top, the judgment would come in your favor. If it came to the bottom, it would go against you. So lawyers would then, artificially extend their argument to say, and that, my lordship, is the ring comes up, the end of my argument. So law is driven by a paradoxical impulse, a drive on the one hand towards predictability, and on the other, the sheer unpredictability and contingency of legal decisions. And structurally, this has a lot to do with the very nature of law, because law functions through the interplay of the particular and the universal. At the level of facts, every single case is a unique case, and it's absolutely particular, especially for the experience of someone who's actually approaching the court. But even as that case shares commonalities with thousands of cases that have gone before it, it still remains a very unique fact. At the same time, the uniqueness of each case has to be subsumed under a set of universal principles for it to emerge as law. Law, therefore, operationalizes itself through the universal, even as justice actualizes itself through the particular. And this is a tension that we will see playing out in contemporary debates around AI and law. Now, it's very interesting to return to the Supreme Court judge and the invocation of the robot to characterize a form of rule following which is bereft of creativity and empathy. And one of the defining questions, right from the 1950s onwards, in the intersection of AI and law, has been about whether it is possible to create a robo-judge. John McCarthy, whose name has come up several times today, the father of AI, and one of the pioneers of AI, considered law to be an ideal test case and candidate for an artificial intelligence approach. Why? Because he said it was text and language based, it was rule bound, and that there was a vast archive of statutes and decided cases which are perfect for machine learning. McCarthy envisioned that facts would be represented in a lower level semantic network, and law would be represented in a high level semantic description, and computers could be trained to apply principles to fact to arrive at a correct outcome. Now, of course, there are many pragmatic concerns that drew or kind of drove the intersection of AI and law, and most of this had to do with the question of backlog. In a country like India, it's a crazy and an almost unimaginable statistic to deal with. We currently have 47 million cases pending in the courts. And as of today, if we stop taking any new cases, it will take us around 400 years to clear the backlog. So we're talking about a situation in which we have a really, really challenging, administration of justice problem. And given the scenario, it's understandable that there's a lot of techno-optimism and hope placed on AI as a potential panacea for many of the structural problems that plague the legal system. And there are various entry points that one can have on the question of AI and law. You can think of it from, as I said, a question of administration, which is about efficiency. You can think about it from regulatory perspectives. We saw in the last previous presentation some of these questions. What are the liability questions that arise, for example, of the driverless car? You can think about it from the future of the profession. Many of the standardized contracts can easily be drafted by AI. So what happens, to lawyers? You can think of this from a philosophical perspective, which is how will AI alter legal ideas of personhood? Then there are the technical legal issues. As the domain of finance, for example, gets increasingly automated, can AI enter into contracts with each other? My focus today, however, is going to be on the question of AI and its intersection with legal research and what it means for the study of law. It requires us, in a way, to examine a central question about the nature of law and legal reasoning and why it lends itself, in a way, to being adapted by AI, even as it fiercely resists it. Important to recognize that law has always been technological. The form and content of law has always been centrally shaped by technologies, in this case, the technology of paper. So what happens with digitization and computerization? Is it only a question of what changes in the way that law is accessed and studied, or is there something inherent about law that makes it amenable, in a way, to computation? And this is what I want to look at today. How do we understand an algorithmic nature of law? One of the most iconic images that you have of law, very familiar to all of you from Hindi cinema downwards, is that of Justicia, the blindfolded lady with scales on one hand and a sword on the other. This image of the scale reminds us that the law is constantly working within the idiom of measurement and outcome, balance, equivalence. And the German thinker Theodor Adorno argues that law is underwritten by a myth of algorithmic justice, which he describes as the fetish of equivalence, the desire for commensurability, and the prevalence of the exchange principle. There seems to be a deep binary logic that is embedded within the logic of law. And this is particularly true in the adversarial system, where one party is pitted against the other. So verdicts are in your favor or against you. You either have legal liability or you don't. You either have to, make a payment or you don't. There's very little room in the adversarial system for maybes. There's very little room for gray areas in the outcome of a legal judgment. As a result, many commentators have argued that legal processes are inherently computational, with inputs in the form of rules, evidence, and facts, and output in the form of orders, relief, and judgments. So even before the advent of computers, legal analysis was often compared to the idea of a computational exercise of equivalences and of balances. So the extent to which a judgment deviated from the precedent. And the very term algorithmic justice was used to describe law even in the analog era. In recent times, a legal scholar, Eugene Wollock, has proposed the equivalent of the Turing test as a legal test. So a legal Turing test to determine whether AI judges can be trained to output valid legal decisions given a particular set of rules and given a set of precedents. Now, it's relatively easy to dismiss these claims as being techno-utopian fantasies that fundamentally misunderstand the nature of legal reasoning and mistakenly assume it to be a science as opposed to an art. But the philosophical roots of these claims actually lie at the very heart of legal philosophy at the advent of modernity. So if you take, for example, Thomas Hobbes, Hobbes considered human reasoning to be a form of computation that consisted of adding and subtracting in the realm of the human sciences, as well as an abstract philosophical inquiry. Hobbes played a crucial role in influencing the great German philosopher Gottfried Leibniz. Leibniz extends Hobbes' insights to law and argues, and I quote, that law attempts to resolve some of the most vexed human questions, from life and health to war and peace, and from individual to collective conscience. And it does so through a reliance purely on human rationality, the balance of reasons, and its scales are used to evaluate the relative weight of competing claims and arguments. So the fantasy that Hobbes and Leibniz had was for law to be as precise as mathematics. And a just legal rule was one that merged abstract legal doctrines with empirical situations. Now, their influence can be seen acutely in legal theory in the 19th and the 20th century in the form of three schools: legal formalism, legal realism, and what came to be known as jurymetrics, or a quantitative approach to the study of law. Christopher Langdale, one of the famous deans of the Harvard Law School, for example, claimed law is a science made of principles or doctrines, and a lawyer's role is merely to apply them with certainty to the ever-tangled web of human affairs. Later, Justice Oliver Wendell Holmes, who also taught at the Harvard Law School, would say, for the rational study of the law, the black-letter man may be the man of the present, but the man of the future is the man of statistics and the master of economics. Many of my colleagues will be very happy with this assertion, and you can take over SLGC as the economics dean of SLGC from now. In the Indian context, there is a lot of very interesting work which I don't have the time to go into, but particularly by Rajiv Dhawan, Mark Galanter, and Nicholas Robinson, looking at a quantitative analysis of the Supreme Court. What I want to do is, if the law is indeed computable, I want to look at three consequences of the law being computable. The first one is the increase in emphasis on law as a predictive science. We've heard about predictive analysis in health. There's a similar debate that's happening in terms of how may legal decisions be predicted and what is the outcome of that. Would it, for example, decrease the number of cases that actually go to the courts? If you are told that you have a 99% chance of losing, would you still go to the courts? The answer is yes, because hope doesn't rely in a way on maths. But there may be interesting things that happen as a result. We're already seeing, for example, new business models. In the US, there is the emergence of what is known as contingency lawyering based on artificial intelligence analysis, where people invest in lawsuits, where monetary damages are of a very high nature. People are willing to fund the entire lawsuit if AI tells them that there is a very high chance of winning the case. There is also, for example, the emergence of what are known as predictive, kind of criminological tools that are used in sentencing. So you have, for example, correctional offender management profiling for alternative sanctions, COMPASS. This is a risk assessment tool widely used in the courts, akin to a credit rating. The program basically assesses the legal profile of accused based on their legal history, and the algorithm then suggests what the quantum of sentencing should be and whether there should be bail granted or not. Now, obviously, the dangers of this kind of a techno-deterministic or a mechanical jurisprudence approach that reduces complex legal propositions into self-evident computational truths is something that's quite apparent to all of us. For critics, the very premise of a legal Turing machine is misplaced because they say that legal problems cannot be mechanically decidable as right or wrong or as 1 or 0. And the whole-scale replacement of juridical reasoning with computational risk undermines one of the principal institutions or purposes of a democratic liberal order, namely the function of the system as a safeguard for individual rights. And this is a case that was fought in the courts in the US, where COMPASS was challenged on grounds of constitutionality and violation of due process. The courts ruled in favor of the software and said that the software's data was only one of various elements used in the determination of legal liability. The second thing I want to look at is what are the analytical consequences of treating the law as computable? And this is really an interesting area of research that is opening up. In the field of digital humanities, one of the most interesting contributions came from the Stanford Lit Lab through the work of Franco Moretti, a literary historian and scholar, where, in law as well as in literary studies, the idea of close reading or textual analysis is really the bread and butter of what we do. Franco Moretti argued that in contrast to close reading, what might it be to imagine distant reading? Which is to say, as the keynote speaker said in the morning, no human can read the corpus of something called literature. just as no human can read the corpus of something called law. So, what would it mean to move away from, let's say, what lawyers do on a daily basis, which is close analysis of how doctrine develops, to look actually at the entire corpus of cases? So, the idea of sentiment analysis as one of the new kind of methodologies in understanding the law, not to get the outcome of a particular case, not to get the outcome of a particular doctrine, but to actually understand something much larger. Give you an interesting example. Prashant Iyengar, a legal historian and scholar, in his work on the family courts and their judgments just from Bombay alone, using kind of technology, analyzed 32,000 judgments to find that 32,000 judgments, the courts repeat a formula. And the formula is that a marriage is based on, quote unquote, trust, love, and mutual respect. So, what does it mean for 32,000 cases to repeat what appears to be both a truism as well as a cliche in almost, ironically, a robotic fashion? How do we understand and how do we use sentiment analysis to ask questions of law and of legal cases of a kind which are not being asked in the present? If, for example, we're looking at entire domains, for example, the entire domain of speech law, which has so much to do with the question of how law understands speech and its relationship to affect. Computational analysis is taking us and opening up a terrain where we are going to be able to look at legal analysis in a truly kind of a deep fashion, which doctrinal analysis is not capable of. The law is not merely made of rationality, it's also made of the juridical unconscious. It contains the biases of the judges, it contains the political history of its time, etc. And in a way, sentiment analysis is something that is actually opening up the possibility of a new field of legal research that actually brings together law and the humanities in an interesting manner. Indian Qanun, which is one of the leading legal databases, is currently doing a lot of AI and sentiment analysis for Indian cases. Fascinating to see what happens. The third consequence that I want to look at is really the intersection between law, language, and AI. Because law has language at its core, and in particular because law is almost entirely expressed in natural language categories, natural language processing seems to be a natural ally for deepening machine learning in law. But this may seem a little easier in theory than in practice, given the diverse nature of legal texts, ranging from statutes, case reports, contracts, and finally, of course, judicial decisions. Because while statutes and contracts may lend themselves to NLP, the world of judicial decisions is a lot more linguistically messy, ambiguous, and in a way relies on an open textured world of language, whose interpretation requires more than merely a semantic understanding of rule following. If you consider, for example, Ronald Dworkin, the 20th century's most important legal philosopher, and his distinction between the rule and the principle. If you take a rule such as all judges shall be appointed as the Chief Justice on the basis of their seniority, in this case, the rule incorporates and exhausts the principle. All of the principle is already in the rule. If, on the other hand, the rule said that a judge shall be appointed as a Chief Justice on the basis of their competence, this is a principle of competence which is very different from something that's already exhausted by the rule. And most legal cases are of this nature. So even if you take a simple sentence, vehicles are not allowed inside this park, it gets a little complicated by specific use instances that demand an examination of whether the word vehicle has any inherent fixed and stable meaning. For instance, if the definition of a vehicle is a mechanic mode of transportation that assists in the movement of people, interpretative disputes in law typically are occasioned when exceptional cases arise. We may safely assume, for example, that a car is a vehicle. But is a cycle a vehicle? What about rollerblades? What about an electric wheelchair? When someone comes into a park in a wheelchair, is that a vehicle? The determination of that question relies on more than merely a semantic analysis. It requires something else. And this is where I'll come to my conclusion. Because thus far, what I've taken at face value is the claim that law is computable. But there is equally a philosophical tradition that seriously challenges this presumption, Martin Heidegger, for example, speaks of justice as the experience of that which is incalculable or a measure of the immeasurable. This returns us to the foundational problem that I began with. Law may be articulated in terms of the universal, but if justice is always individualized, it's this tension between the universal and the particularity of justice that makes it difficult to generalize into an abstract algorithmic logic. AI may attempt to mimic the algorithmic aspects of justice, but there is an additional dimension of justice, which is that of the poetic, that defies calculation. In the early days, before the Narmada Bachao Andolan became the NBA, a petition was filed at the Gujarat High Court before Justice Thakkar, in which it was argued, because at that point in time what was being challenged was cash compensation for land. The petitioner argued that the word life in Article 21 should not just mean cash for land, but that life should mean a sunset for a sunset, a running brook for a running brook, and a grove of trees with shade for a grove of trees with shade. Now, this is not a rational argument. It's not subsumed within an algorithmic logic of equivalence. It is an enchanted argument that affirms Oliver Wendell Holmes' famous assertion that the life of law resides not just in logic, but in experience. We are at a threshold of a brave new world that demands us to rethink both logic and experience. And the prospects are as exhilarating as they are terrifying. Thank you.
A very good afternoon to all of you, respected ma'am, and all the deans, faculty, and research scholars present here. The title of my talk today is Artificial Intelligence and Predictive Modeling. So in Delhi Technological University, I am in a group headed by Professor Yogesh Singh sir. He's now the Vice Chancellor of Delhi University in the area of machine learning with a long list of members in our team, including research scholars, faculty members, PG students, and UG students. Before I begin, AI and predictive analytics, artificial intelligence, with the subset of artificial intelligence is the basis is predictive modeling and machine learning. So I'll today cover the basics of predictive modeling and the research methodology behind predictive analytics in my talk. Talking about everyday artificial intelligence. When I talk about everyday artificial intelligence, as I open my mobile phone to type a message, the auto suggest on the mobile phone uses machine learning and artificial intelligence to suggest me some words. If I type WH, so it suggests me what or why. So that's an example, a classic example of everyday use of artificial intelligence in our day-to-day life. Second example that most of us use very often is Google Maps. Google introduced machine learning to Google Maps in 2017. Google Analytics and Google cars are very popular in US, and they go from place to capture the images. And as one of the speaker told us, that they take demographics of people from those images, from the information or to where they are living, what kind of living standards they are, and so on. Machine learning helps us to the app to extract the names of the streets and the house numbers from the images and the photographs that have been taken. Third very classic example is online recommendation. As soon as I open my Facebook, it gives me many recommendations, starting from the books that I may like to purchase from Amazon to the clothes or kind of things I may like to purchase from Fab India. That is another use of artificial intelligence in our day-to-day life. Coming on to predictive modeling, which is a subset of artificial intelligence, and it is the basis behind any application in the area of social science, any application in the area of management, or any application in the area of electronics or computer or software engineering. It is the basis of all those. So I'll just give you a brief idea about predictive modeling and what step as faculty and research scholar and what things we should focus on before we move ahead on the use of AI and machine learning in various areas, such as have been highlighted by my previous speakers. Predictive modeling, before I begin, what is predictive modeling? Basically, it's a process used in predictive analytics to create a model that can be used for predicting behavior, future behavior. For example, let's consider weather prediction problem. I have humidity, I have pressure, I have temperature, and I may like to predict whether it will be a sunny day, it will be a rainy day, it will be a windy day, or it will be a cloudy day. So that's an example of predictive model where we use historical data along with data analysis technique to make future predictions. So it's a very important application or a subset of artificial intelligence which has gained lot of importance in the past. Predictive model is made up of a number of predictors which are variable factors that are likely to influence the future behavior or results of the model. Historical data is the basis of predictive modeling. Historical data is considered for extracting predictive rules which are then applied on future data. Historical data can be collected from various sources. In management and social sciences, when we talk about management and social sciences, it is generally collected from questionnaires, surveys, and those questionnaires and the data gained and obtained from those questionnaires and surveys, it goes through a reliability, internal and consistency and validity checks, and after that through SEM analysis and through various statistical techniques and machine learning techniques, we can analyze that data. So coming on to the diagrammatic representation of predictive modeling, as you can see, historical data for training is given to the model, and we can use any data analysis technique. When I say data analysis technique, I mean either a statistical technique or a machine learning technique or evolutionary technique. When I talk about statistical technique, it may vary from logistic regression, linear regression. When I talk about machine learning technique, it may vary from random forest to decision tree to neural network to deep learning. And these days deep learning is a very buzzword, and where as a research scholar and faculty we are attracted to use deep learning in our various studies. And when I say evolutionary, it may be particle swarm optimization, it may be a genetic algorithm, or it may be any search based algorithm. So out of these models we do extract predictive rules, and those predictive rules are applied on a new data set to create to make future predictions. So this is the whole the broad idea behind predictive modeling. Now coming on to what are the steps involved in predictive modeling. First is the collection of data. Collection of data, it depends upon the application, as the various my previous speakers have given vast number of applications. So it depends upon the application type from where you can collect data. And one of the very popular medium to collect data in management is questionnaire, and through questionnaires, through surveys and so on. Then a very important task is to select an appropriate technique. So in my presentation, I will focus on, rather than focusing on an application, I will focus on how you should select an appropriate data analysis technique for developing a predictive model. Then comes data cleaning, data pre-processing. That part includes outlier analysis. The points that lie very, very far away from the mean of the data are known as outlier. So this step involves cleaning the data through outlier analysis and missing data analysis. The next step is given a vast variety of variables that we have. For example, in weather prediction problem, I highlighted 3 variables: temperature, pressure, and humidity. Similarly, in various problems, we do have a number of attributes, variables known as independent variables. I'll just soon define briefly what are independent variables. The variables basically that are used as input variables and that are used to predict the outcome of the data. So that are known as independent variables. So attributes, so we may have a range of variables. So we need to apply appropriate attribute subselection techniques in order to reduce the redundancy and in order to select those variables that are actually relevant in the research. The next step involves development of a predictive model by using training data set. And then the predictive model is validated through a set of techniques. These days we do use different techniques to validate a model. In order to reduce the biasness of the model, we should use an appropriate technique for validating the model. And finally, the model that has been created using a data analysis technique, it is used for predicting the future instances. Now, whenever we think about creation of a predictive model, it's a carrying out of an empirical study, which is a 5 phases procedure of carrying out the study. First, very important procedure is process is the study definition part. So when I say study definition, I mean defining the dimension and scope of the study, defining the purpose of the study, defining the motivation of the study, defining from whose perspective the study is being carried out, and finally defining and determining the context of the study, the domain and the perspective of the study. So these are few very important steps in study definition. The next very important step in creation of a predictive model is experiment design phase. It is the most important phase where a systematic literature review is first carried out. Then we form research questions. Then finally, the hypothesis is formulated. Hypothesis is the assumption of the research. After that, the variables are defined. The independent and dependent variables are defined. Their type is defined. Data is collected from appropriate sources, and an appropriate data analysis technique is applied and selected. And finally, very important step in experiment design is determining the threats to validity. That means the limitations of the research. So whatever the limitations of the research, they are determined in very initial phase so that they can be mitigated at a very early stage. The next phase involves research conduct and analysis. In this phase, we summarize the data through various measures of dispersion and central tendency, such as mean, median, mode, variance, and standard deviation. After that, the number of attributes that we have, they are reduced through a class of technique, and then through various statistical analysis techniques, the model is created using the data analysis technique that we have selected in the previous phase. And finally, the hypothesis testing, the assumptions that we have made in the research, they are tested and the results are reported. The next phase is result interpretation. In this phase, the theoretical and practical significance of the results, along with the qualitative and quantitative analysis of the results, is carried out. The conclusions that we have got of the hypothesis testing, they are drawn, and the limitations are now reported. We tried to reduce the limitations, but the limitations that remain, the threats that remain in the study, they are reported in this phase. The final phase is the reporting stage, where the results are presented. It may be, if you want to present it as a part of a project, or as a conference, or a journal article, or a technical report. It depends, or a master's thesis or a PhD thesis. It depends upon the venue of the publication that the results are presented. And finally, the ethics of the research are highlighted along with the plagiarism. So I'll just quickly summarize each of the steps, focusing on the very essential parts in predictive modeling, and then I'll conclude my talk. The first step involves, as I have told you, the study definition. It has so many parts, going from defining the dimensions of the study, going up to defining the purpose of the study, why we are carrying out the study, which entity is being studied, when I talk about software engineering, whether I am studying a product or I am studying a process. So it's very important to define the object that is under study. From whom's perspective the study is being conducted, from managerial perspective, from a tester's perspective, from a developer's perspective, from an analyst's perspective, from a customer's perspective. So it's very important to highlight from whom's perspective is the study being conducted. Then finally, what is the area, the domain of the study is defined. After the defining the study and the scope and the purpose and the motivation of the study, the second very important and the most significant phase is experiment design phase. The design of the experiment, it covers lots of things, starting from establishing the research questions, formation of research hypothesis, selection of appropriate research variables, collecting data from appropriate platforms, selecting appropriate data analysis method. Why I am highlighting on the word appropriate is because normally we don't follow a signified procedure for collecting data or selecting an appropriate data analysis method. So there is a way in which a particular data analysis technique or method can be used. For example, deep learning is not applicable on the data set that is not large or is complex. It's only applicable if your data is very, very, very large and complex in nature. So the precondition of a particular data analysis method or a technique should be satisfied before going on the application of that technique. The context of the study is also defined in this phase. So just summarizing on the steps in the experiment design, first step is understanding the problem, identifying the goals and developing the research questions. That these are the research questions that you will address in the study. Then second step involves exhaustive literature review, exploring various digital portals such as IEEE, ACM, Springer and so on, and critically analyzing the papers, the current research publications to extract the details of the existing publications and what actually is lacking in those publications and how our research will benefit academicians, researchers, or society in any way. The third step involves formulation of hypothesis, selecting important research variables and collecting the data, and followed by an appropriate selection of an appropriate data analysis technique. When I talk about research questions, this step states the problem in form of questions and it identifies the key or the main concepts or the main relations that needs to be explored in the study. For example, what will be the effect of object-oriented matrix on fault proneness of a class? So this kind of things can be explored, needs to be stated in form of research questions in this phase. Then comes reviewing the literature. So this step basically involves critically reviewing, extracting the research publication data related to the area and critically reviewing them. After that, the research variables are identified. Broadly, research variables are of two types, independent and dependent variable. Independent variable is a variable that can be changed or varied to see its effect on the dependent variable. Thus, the dependent variable is dependent on the independent variable. After identifying these variables, we need to identify the type of the variable, whether they are of categorical type or they are continuous in nature. They are nominal, ordinal, ratio, interval, or absolute. So it depends on the type of the variable that we will carry out or select an appropriate technique. Okay, so after selecting the variables, the next step involves formation of the research hypothesis. Hypothesis, as I've already told you, it is the foundation of the research. So after research hypothesis formulation comes very important step of data collection. Data can be collected from many sites, and when I talk about social sciences, I need to plan, and that's why the ethical issues also comes into consideration. I need to plan the sites, the questionnaires and the surveys, and to do reliability and validity checks of those questionnaires and surveys in order to collect the data. Now comes the very important step of selection of an appropriate data analysis technique. So there are three important parameters that need to be considered when we are selecting a particular data analysis technique. First, the type of the dependent variable. Second, the nature of the data set. And third, various important aspects of different algorithms. When I say type, I mean whether it's binary in nature, categorical or continuous in nature. When I say nature, I mean diversity in the data set, redundancy in the data set, type and existence of interaction amongst variable in the data set, and size of the training set. And finally, very important aspects that need to be considered while selecting an appropriate statistical or machine learning technique is the accuracy of the technique, the speed of the technique. It refers to the time that is required to train the model, the interpretability of the technique, the ease with which you are able to understand, and the simple the algorithm is, so the better it is. So all these aspects need to be considered and analyzed as a faculty and research scholar before selection of an appropriate machine learning or a data analysis or any statistical technique. Then comes the threats to validity part, where we do identify the threats and we devise strategies to reduce or minimize those threats. The next step involves research conduct and analysis. So in research conduct and analysis, as I can see, there are various steps involved. I'll just briefly introduce those steps. First is matrix data analysis, where we summarize measures of dispersion and measures of central tendency. along with outlier analysis, along with correlation analysis. Then comes attribute selection and extraction part. Either we select important attributes or we extract them, the important attributes, maybe through correlation based techniques, maybe through principal component analysis, and so on. Then comes hypothesis testing. So we have two type of test parameters: parametric test and non-parametric tests. Then come performance evaluation measures. So whenever we create a model, we need to select appropriate performance measures, maybe recall, precision, accuracy, area under the curve, G mean, G measure, F measure, and so on. Model development. So the technique we have identified in the previous step, model is developed using this technique. Then the model is validated, and finally we do model comparison test through Friedman test or using post-hoc tests such as Wilcoxon sign rank test and so on. So this is the whole architecture of using machine learning for predictive analytics. So as you can see, the first step involves collecting data from historical repositories, training instances with binary class C1 and C2, as you can see in the example, have been corrected. Then applying an appropriate machine learning technique, creation of a predictive model, and that model can be used to predict the future instances. The last step is the result interpretation step, where we do interpret the practical and theoretical significance of the results. And the issues that we need to address in this step are very important. First is, does the results support the research hypothesis? If yes, why? If no, why? Who will be benefited by the results? Academician, researcher, society, or any other entity? How does the study relate to the past or the previous study? What are the lessons learned from the study? And finally, what are the limitations of the study? So the result reporting part depends upon the venue of your the publication of the result. The last step, very important in social sciences too, is ethics of empirical research. So researchers, academicians, and sponsors should be aware of research ethics. So in our software engineering branch also, the most important step is that we follow ethics while doing empirical research. So an unethical study can harm the reputation of the research conducted in the area. Last step is, I do always, when I summarize my talk, highlight on the plagiarism. We do know about plagiarism, but still, the reuse of someone else's prior ideas, processes, results, or words without explicitly acknowledging the original author or the source is known as plagiarism. We have strict UGC policies, a policy to deal with plagiarism. So in any case, all the reports, all the research projects that the students do, we do need to follow this strict guideline of plagiarism. So this was from my side. Thank you so much.
Very good afternoon to all. Let me thank the organizers for giving me this opportunity. I am going to talk about role of AI in heritage restoration and preservation. Professor Shantanu Chaudhary was talking about many research problem, and this is one of the research problem where social science people can explore. So basically, I will be going through the challenges in preserving cultural heritage, applications of digital preservation, challenges in AI-powered preservation of heritage, and role of AI in heritage education. This is the way I am going to continue. See, basically, digitization means it is not taking a photograph in as per computer vision people. Digitization means you should be able to analyze the, like for example, the OCR is one of the output of computer vision through which actually we can read as well as we can edit the text which is coming out as a OCR text. So here, like this is an image of an old inscription in Hum'ble. The lipi is Brahmi. So Brahmi Lipi is the one which is actually which evolved as different languages. So it started like there are certain text I have seen where the evolution of the lipi from Brahmi to, in Sanskrit itself there are 4 lipis: Sharda, Sharda, Nandinagari and Nevari. And then now, but what we are seeing as Sanskrit is Devanagari. So this is actually evolution which is coming from the Brahmi Lipi only, and even all other languages also. If you think about Bengali or Malayalam or any language, it is basically started from this Brahmi Lipi. So computer, see this, the AI can, or the computer vision problem can be one to transliterate the lipi, the text which is available into the inscription as well as manuscripts into Devanagari Lipi so that we can read it. Actually, we can read it and we can analyze it, because nobody knows the Lipi which is Brahmi right now. So this is one part of this we have taken from Bhagavad Gita, which is written in Sharda language. Again, this is Sanskrit only, and we took the help of one scholar from IGNCA, and they have translated this. Whatever is written in Sharada is converted into Devanagari Lipi, which we can read. Okay, so basically why we have done it is, see, using computer vision algorithms, we will be able to transliterate from this lipi to this. See, this part is the output of the program which we have done. This is basically, here we can read it. See, if it is, if it can go through the Sanskrit OCR, the result will be like this. But from the manuscript data available, we can convert it into this language. See, it is not, we are not following the pattern of the letter here. See, you can see these 2 letters here, that is similar to Ma, but one place it is Sa. It is written as Sa, like this line is being utilized. This is looking like Ma only, but here it is Sa, but here it is Ma. So this is basically this. There are differences in the languages. So many characters are similar, but so many are similar to Devanagari also. So the difference we have to identify. That identify will come from the knowledge of the lipi. This is one inscription in Hampi. This inscription also, that's what I told you. Digitization means just not by taking the photograph. We can, this is, here we can analyze it, and we can even edit the word. So digitization of the, again, this has also a lot of problems, research problems, like certain things may not be coming as the clear output here. So those things can be, AI will be able to help us. See, this actually, for this, the other language was Telugu, and which we do not have that OCR part of it, so we could not do it. But English we can do it. This is English inscription, and this is the digitized output. But if you can send this to the OCR, we will be able to read it. So basically, we should know the lipi. That is it. So the knowledge is coming from the lipi. Then only we will be able to convert it into readable one. So this was about the text manuscripts. See, in Professor Babatosh Chanda sir also said that we can search certain data from the manuscripts. See, for example, in IGNCA, there are a lot of documents related to manuscripts in Ayurveda. Even those manuscripts are also written in either in Sharda or in Nandinagari Lipi. So we can, Ayurveda has got lot of solutions for diseases. So if we can make search engine based, if you can make a search engine in that, for that also again the knowledge of that lipi is required. So if only those people and computer vision people, if we sit together, we'll be able to solve that issues. Similarly, traditional art forms. I am showing only Bharatanatyam here, but there are a lot of other traditional art forms. Folk dances are there. Traditional music is there. So many things are available. India is rich in culture and traditions. And even these sculptures, many sculptures people are making. So for all such art forms can be digitized and can be that if you are not preserving it by digitization, we may lose it. So this is one of the oldest painting which is from Ajanta cave, and we can restore. This is actually restoration. We can from other places you will be able to find out the similar images, and you will be able to restore it. Even such paintings, another thing is that we can even embed a story on it, so that if in the digital space, if you click it, you will be able to hear the story of the painting behind it. Such things are not explored right now. So this was even Professor Shantanu Chaudhary also showed this. This is the chariot where this part is missing here. So from the information available in the literature and the scientists who are working in this field, we have, after discussing with them, the computer vision people has restored it. This is something restoration problem. Ajanta cave image, again we have to preserve this digitally as well as physically also. See this, and these are some of the, till this time I have used my work, but these are I have taken from images from the internet only. These are internet images only. Here you see the manuscript is in again Brahmi script or Prakrit Sanskrit. See, there are a lot of, we will not be able to identify what is written here unless and until we have the knowledge of the script. And at the same time, there are a lot of other challenges in this as a computer vision problem, because there are reflections coming in. Imaging itself is, we may not be able to utilize the image directly. We may have to go for multimodal images and all. So we can say that the cultural heritage information can have wide variety of problems: social identity, health, well-being, poverty reduction, tourism, increase in scientific knowledge, agriculture, sustainable, consumerism, environmental awareness, creative industries, education, learning, medicine, etc. So many things are there. If you look into all these things in cultural direction itself. So these are some of the heritage cities in India. These are some images I am showing, that's all. And these are some of the cities, earlier cities, that is where Ujjain, Nalanda, Rameshwaram, Shantiniketan, Haridwar, all other cities. Even preservation of these cities in digital area is required. For that, we need people who knows about these cities in detail. Then we know that we are the food, medicinal importance of the food we are having. Even these things are also to be preserved digitally. That is going to be. And traditional like legends, folk tales, proverbs, music and song, all these things, all some of the cultural or traditions which we have, which we can preserve it. So some of the story, like and from the Ajanta Ellora caves, and these are some languages which we may have to retrieve, like we have to preserve. Digital preservations are required in this. Similarly, we may have to preserve the people, like the thoughts of the people, and like Rabindranath Tagore, he has done a lot of things, created Shantiniketan, then Tagore believes true modernism, and actually he has done lot in education also. That is, education should be based on imagination, pursuit of science, rootedness in culture and art, not unreasonable traditionalism. So such kind of, there are a lot of things which we may have to look into, and then these has to be preserved digitally, and at the same time it is to be analyzed also. Mahatma Gandhi is another person. Similarly, we have many other people, and some of the temples which are actually getting like we may not be able to see these temples right now. So these things are to be. So with this, I am concluding my talk.
So good afternoon, everyone. First and foremost, I would like to thank the speakers for inviting me as a panelist. And in our education system, the computer scientists don't get to mingle with social scientists too often. So I really jumped at that opportunity and thinking it'll be good to learn from some social science from experts. So we have seen, we have heard and seen the number of ways in which AI can do social goods. I'm going to show you a little bit of downside, and which calls for the intervention by social scientists. So as we progress, I will talk about it. So just a brief introduction to intelligence. A human intelligence consists of perception and cognition. So the artificial intelligence is all about learning how to simulate speech and vision in computers, or how to simulate language, how to simulate reasoning, problem solving in computers, and that is done through algorithms. And the algorithms, as in one of the earlier presentations by Professor Ruchika Malhotra, we got deep insights into how the learning takes place. I'll give you a very high level idea of how the AI is created. So we take a lot of data, right? And then we develop algorithms, either machine learning algorithms or deep learning algorithms. These algorithms, they process the data, they analyze the data, and they try to extract some patterns. And these patterns are stored in a yeah. So it's a very high level a pipeline for artificial intelligence. So a lot of data is taken, the algorithms are developed, these algorithms analyze the data, and these algorithms then try to figure out the patterns, and these patterns become, they are called the model. They are stored in what is called the model, and these models, they make all the decisions for whatever reason the model has been created. And these, as in one of the earlier presentations we saw, that these AI models, they are touching our lives right from the morning, when we see WhatsApp after getting up, and right, when we go to the bed and see WhatsApp before we, so they're touching our lives every day when we are awake. So now AI is actually a double-edged sword. We have already seen all the good things that AI can do and has done. So in healthcare, AI has been used to discover drugs, which was not possible by performing experiments. Then in education, by personalized training, we can reach out to regions where the students do not have access to the facilities, right? Then farmers can benefit from AI, because so they have sensors which can figure out the moisture in the soil, the humidity in the air, and then decide how much water is to be given to a plant. Or if the image is taken, it will be able to tell the farmer what are the possible reasons for the wilting away of the plant, what are the possible diseases. right? And then language technologies we use all the time, Google Translate. If we are traveling to a country where we don't know the language, we use Google Translate to communicate and work, right? But the questions that I'm going to now raise is, are artificial intelligence is always making decisions for us. So are these decisions fair? I mean, we have to ask these questions. Now, is AI accountable? Because AI is taking decisions. So if the decision is wrong, who do we hold accountable? Right? Is the data accountable? Is the designer of the algorithm accountable? Or is the user accountable? Then the decisions that are taken by the artificial intelligence, are they transparent? So if I apply for a loan and my loan is denied, right? If there was an executive who was looking at my application, I could have gone and fought with him that how can you reject my application because I am fulfilling all the conditions. But if it's a machine which has rejected, I have no one to fight with, right? I'll go to the executive say, I cannot do anything, the machine has rejected. So I have nothing to do except to get frustrated and probably go to another bank, right? So then, because of all these issues, so these are the ethical issues which arise when AI is penetrating deep into our lives. So it is here that we need to align the AI with the human values and ethics. So the most common and troubling issue with artificial intelligence is the bias that is there in the models. We don't even know that bias. So there is bias in there's a gender bias and there's a racial bias. Now, gender bias, I'll give you a very simple example and you can do it at home. Go to Google Translate, right? Translate from English, from Hindi to English and back. So you type, he is a doctor, she is a doctor, he is a nurse, right? So I am associating the male gender with the nurse and the female gender with the doctor. You translate it to Hindi and translate that Hindi back into English. And then you will see that it always gives you, she is a nurse and he is a he is a doctor. So the the Google artificial intelligence which is translating associates a doctor with a man and a nurse with a woman. So this is the gender bias. I mean, this is a very simple example which you can do it after you go home. Then there is a bias in computer vision. So the face recognition, the artificial intelligent models which recognize face or which process image, they show a lot of gender bias. I'll show you some examples there. In employment practices, there is a gender bias. So if I'm an employer and I have a repository of resumes, right? And I'm using AI to pick up resume. So if I say that I need some resumes for a software engineer, all the resumes that are delivered to me, they are male. These resumes belong to male experts. And if I ask for the resumes of receptionists, all women resumes of the females will be delivered. So the AI is biased. It always associates tasks and professions with the genders, right? And so I'll show you some examples. And racial bias in computer vision and NLP technologies. So dark-skinned people, the decisions for dark-skinned people are different from the decisions for white-skinned people. Decisions for even in healthcare, there is a racial bias. In US, so all the cases that I am just describing, they are well documented in AI research. And there's a racial bias in healthcare. And Professor Liang, he raised some questions about the applicability of AI in judicial processes in law. So in police and legal processes, America has now in number of states, they have retracted the use of AI in recidivants and other police and legal processes. So in 2015, there was a big embarrassment was Google. So that was the time when, deep learning came around in, the breakthrough of deep learning came around sometime in 2012, and another 3 years it picked up, and 2015 Google unveiled a software in Google Photos which could instantly tag people. The moment you upload your photo in Google Photos, it will tag. So two Americans of African descent, they went for a vacation, and they uploaded their photograph, and the Google immediately tagged them as gorillas. So that was a very, very, very big embarrassment for Google. Of course, they corrected it over time, but such similar incidents are likely to occur even now. Now, the errors, so in face recognition, white men are recognized highly accurately, but dark-skinned women are not recognized accurately. The AI makes the percentage of error that AI makes in recognizing dark-skinned women is much higher. Now, in image recognition, again, there is a problem. So this is again documented in a scholarly text. This happened in COVID, right? So a white man holding the thermometer, infrared thermometer, which is like a handheld thermometer. So I'll just show you the picture here. So if a dark-skinned man is holding that thermometer, the AI recognizes the device as a gun with a very high confidence. And the white man holding it, it is identified as a monocular. So this is the kind of bias which is embedded, which is not very apparent. So unless it touches us, we will never even realize that. But we could be victim of it anytime, any day. So pedestrian detection systems are really dangerous. So it has been shown that in dark, right, autonomous vehicles where the driverless cars, so in dark-skinned people are not recognized easily. The machine makes a lot of errors. So is this ethical? That a white-skinned person will be detected, and the autonomous self-driving car will take action to save it. But what happens to a dark-skinned person, right? And captioning algorithms. So you can give you can give an image, and the AI will generate a caption for this. So this is a picture of a woman sitting in front of a laptop, right? So the caption that is generated is man sitting in front of the computer. Now this red area that you see here, that is the focus of the AI algorithms, AI model, right? So it sees that this is a laptop and there's a person sitting, but it does not recognize a woman sitting in front of a laptop. It always associates a man sitting in front of the computer, right? So these are the small problems which have now been realized. So AI in US has been used since I think 2014, and slowly it has creeped into a lot of governmental processes, judicial processes, and of course a lot of corporates are using AI for different tasks, but only in healthcare, right? So in healthcare, what is happening is, so the dark skinned people, they are denied insurance, and the white skinned people, they get with the best healthcare facilities. So these are all documented facts. So the implication of the lack of fairness, accountability, transparency, and ethics, right? The sociological biases, they hurt people in unfair ways. All right. So if there is if there is a hospital admission to be made, this has to be made in a completely fair way. So you cannot make decisions on the basis of the economic status of the two patients or on the education status of the two patients, right? It has to be done on the basis of the medical condition of the patients. So the AI systems they are not only biased, they amplify the bias. How? Because as we see that the AI systems are created from data, and this data is collected from all over the net. So everything that you have ever written and posted on net, whether it could be a post, it could be a blog, it could be a research paper, it could be a book, anything, or any image. So all that has been used to train the models, right? Now, so if there is a bias in the internet, I mean, all humans have some biases, and that bias is reflected on every on all content that exists on the internet. So this bias is now amplified once it gets into the model, and it is even perpetuated further. So now this is again the social and political disruption is again a very serious potential problem. So we have now generative AI, which can generate text, which can generate images. So fake misinformation, fake news, fake videos, fake images, they have the potential to disrupt the society, and they have the potential to disrupt the political system, right? And finally, what about the legal liabilities? That is another implication that one needs to think about. So, and here it is here that the role of social scientists becomes very, very important. So in our country, somehow computer scientists, AI creators, right, and social scientists, they have been working in silos. But now is the time for them to intermingle to solve the problems. In our country, we are just at the threshold of introducing AIs in processes. Right? So about 5 years back, Niti Aayog gave a document for the AI vision for our country. So before AI goes deep into our lives in India, right, we should learn the lessons from the West, right? And there and the role of the social scientists is to question all these things. So creativity. So suppose you write poems, right, and you load it on and you post it on net, and these poems, these poetries, or if you're a painter, if you're an artist, if you're a musician, you load all these things on net, and the AI that has been trained, that has already been trained on your content. So what happens if I use AI to generate a poem and publish it in my name? What happens to the copyright, right? So there are a lot of complicated issues that we now need to think about, and I think this is the time that we get sensitive about it. The computer scientists and social scientists should get together to identify the issues, right, and propose solutions. So we need to develop regulatory frameworks. Now, regulatory frameworks for deployment, not for research. The computer science research or the AI research should not be constrained, because there are tremendous uses of AI which can benefit humanity. But before the deployment is very, very crucial. So as Dr. Ashok Chaudhary mentioned, that a number of startups have come up, right? So but what are these startups ensuring that the AI that they are using to make decisions about diagnosis, are they safe? So before deployment, it's a responsibility of the government and academicians together to develop the framework, to develop regulatory frameworks, so that general, I mean, the people are not affected, right? They are not harmed. And the second very important point I think that the social scientist must do is to generate awareness in the community. And the AI researchers also have an important role to play to communicate and educate even them ourselves. Like I, as an AI researcher, I also need to educate myself from the potential pitfalls, the potential dangers, right? Unsafe AI. So that is all I had to say, and thank you very much.
On behalf of AUD, I'd like to thank all of the speakers for extremely interesting and provocative presentations. Since we're running late, I'm going to hit the ground running. Unfortunately, Dr. Ashok had to leave for a medical kind of emergency. When I was walking down, it was like watching a live episode of Grey's Anatomy. The doctor was running away for a surgery. So, one thing I wanted to say just as an opening remark is, at any moment of a transition in a technological moment, there is a dual kind of an impulse, both of a techno euphoria, with the presumption that the technology is going to solve everything in the world, as well as a techno kind of phobia, which says that, well, here is yet another, pronouncement of a technological moment. And it might be interesting to actually historicize this. If one looks, for example, at the history of the book, we presume the book to be a stable object of knowledge that we take for granted. We recognize it, we recognize its conventions and its forms. What we don't often remember is that it took almost 200 years for the book to stabilize as an object of knowledge. In the early days of the print revolution, the number of battles that took place around questions of authenticity, of error, of the desacralizing of what the scribes used to do as the copying of holy messages, etc. So, in a way, the question of authority of knowledge and the question of trust is not inherent in any technology. It has to be grafted upon that technology. And the grafting is really the question of the social and the political. And for all of us at AUD, at the end, when Professor Bhatnagar was speaking, there was a moment of recognition. Finally, questions of class, caste, gender, sexuality, and all of the political questions have finally all arisen. So it was a perfect kind of an end. But in many ways, all of the questions that you raised are precisely those points of intersection. But one of the challenges in an interdisciplinary conversation is always that of language. It's almost as though the technologists and the social scientists don't speak the same language. And if we are saying that the conversation between them is an imperative, we'll have to think about how we cross that language. With that, I'll open it up to the audience. I'm sure there are a lot of questions. Kritika. I saw your hand.
I asked instead of Kritika then. So, the childhood friend, so I just replaced her. Okay, so my question is specifically to Dr. Prama. Okay. So a lot of policy interventions that you had mentioned, and particularly I'm interested in food security and resilience efforts. They involve collection of sensitive data about individuals, about communities, or even specific food supply chains. And then there are also issues related to infrastructure such as access to data, training and skills, the cost required. So how do we overcome these challenges so that we can truly exploit the potential of AI to provide solutions for some of the most pressing developmental and social issues that you had talked about?
Hello. Okay, yeah. Thank you for the question. So, so there are two aspects here. So one is collecting various sources of data, and the other is the issue of sensitive data. So there exist several tools in the AI ML domain that allow you to combine several sources of data. Okay, so some of the speakers talked about this natural language processing. So that allows you to convert text data into some form of quantitative data that you can combine in your model. So I think AI, the developments that have happened in the AI and ML space are currently well equipped to help you to do that. But the issue that is most pressing is around sensitive data. Now, the ML or AI isn't going to particularly help you in the problems that come from sensitive data. So you would need, if you believe that that sensitive feature that that you're trying to collect is a very important thing in your model, then the issue of ensuring that the data doesn't fall into wrong hands lies on the researcher. Okay. So one of the ways in which researchers typically do it is when they publish, they anonymize the data, or they'll generate synthetic versions of the data and not the original one that they collected. Okay. And there are AI tools to help you do that. Okay. So the data masking, we call them data masking. There are tools that you can use to allow that sensitive data doesn't fall into wrong hands.
There is no tea unless we have at least 4 questions. So don't think you're getting away easy. Preetpal and Yogesh, taking one for the team.
Thanks, Lawrence. Actually, this is something this comment I wanted to make in the morning session, but now that you've said that we won't get tea, so I thought that I'll make it now. So actually, it's not directly related to any of the presentations, but also related to all the presentations. The larger question of technology and power, basically. So in artificial intelligence in the recent few months, a lot is happening in the West where people who have actually created AI, person like Jeffrey Hinton, who is considered as a godfather of AI, he has resigned from Google, and they have started a campaign against the lot of issues, not just ethical issues, but lot of existential issues which are linked with the question of AI. So on one hand, we see in the West, there are people who have created AI, they're coming together and they're questioning themselves what they have created. On the other hand, we in the East or in the global South, we are rushing towards what they have created to adopt or adapt here. So I would like, if any one of you in the panel would like to comment on this. I would like you to comment on this particular thing which is happening at a very larger scale at the moment. Thank you.
Yeah, thanks. That's a good question and a good thought too. Jeffrey Hinton resigned about 3 months back from Google. He had been serving Google, and the reason he said that is that if I'm taking money from Google, I would not like to speak anything about the products which can harm Google. So that's what he said. And not only Jeffrey Hinton, there's another I'm missing the name. Timnit Gebru, yeah, she resigned from Google. So there are a couple of people who are now discussing the existential threat that can. Sorry? No, not Elon Musk. So no. So I'll tell you about. It's a very interesting thought experiment. So if the AI becomes super intelligent, right? So and it has been taught or it has learned to optimize whatever it does. And suppose that AI has been AI has been asked to create paper clips. Paper clips we use to hold the papers together, completely harmless, right? Now suppose that AI has been
taught to make paper clips and maximize the production, then it will transform everything. Suppose that's possible. So it will transform everything into paper clips. And because it has been taught to maximize the production, it can even convert human beings into paper clips. So that causes this causes a question, or rather fear of existential threat. So earlier, people used to think that existential threat is not real, because to wipe out humanity, the AI should be able to move, right? But the robots were not very mobile. I mean, very not smoothly mobile, right? So, but now people feel that without weapons, AI can really harm humanity just by spreading misinformation, fake news, and fake videos. So the what is happening is people will fight amongst themselves. They'll group, they will fight, and they'll harm each other. That ultimately is going to harm the humanity. So that, yeah, a lot of AI experts are now realizing the potential dangers of AI.
Would anyone else like to step in on this?
I think one of the questions was towards the end that there are people in the West who are moving away from some of these large language models or generative models, whereas we are here trying to adapt some of it. So I just want to make a point that this space of AI and machine learning is actually huge, and so there are components within that can still help us. So it's important to understand that it's not a monolith. It's not like one algorithm or one robot. There are individual components that can help us. You've heard examples from so many panelists where AI is actually helping us. I think the main takeaway is that don't lose your common sense or take everything with a pinch of salt. Yeah.
No, I am asking a question maybe out of ignorance, so please pardon me if I am wrong. But I'm really bewildered by the pompousness with which AI has actually been introduced as a tool, interpretative tool or learning tool within the AIM. But what I'm trying to say is the way it was presented to us today, that AI is something that we have to adopt, to kind of embrace, as the session actually started today. And we are ending towards more skepticism, which, as Lawrence was also underlining, perhaps is we are heading towards more social science approach than we started with. Now, and keeping that and bearing that in mind, I'm kind of, as a historian, raising one very small point. But the way we try to understand history, we try to understand history and particular data in history through maybe two set of, if I were to use data, I would perhaps use it through two set of assumptions. One, which is a contemporary data. Contemporary data is the data that you have a control over. You are still collecting it. You still know what are the limits of a contemporary data and contemporary knowledge, for instance. But then you have a data that you have acquired over a period of time, like human memory, say, for instance, which is constituted of both genetic, which is constituted of violative, which is constituted of trauma, which is constituted of all kinds of things. And so is data. A huge historical data which is constituted of all kinds of biases, which will also get fed into, as Professor Indu was also trying to understand, fed into an organism that artificial intelligence would become. Is there a way to kind of reconcile with these two differing kinds of data? A data that you have a control over, it's contemporary data that we are still collecting, and historical data over which you don't have a control, because computers applications may not be able to decipher philosophically, intellectually, the data which is still is there, and you can't do anything about it. So when something like a statistical analysis, say for instance, has to be done, I'm not from statistics and therefore I'm asking this question in terms of ignorance. What do you do in a country where even a census data may not have been collected, scientifically? What do you do in a country like that? What do you do in a country where COVID death data can be suppressed? You see, so what I'm trying to ask, therefore, is when you think of something like predictive analysis, which sounded like a bomb on my head, predictive analysis, as if you can predict the future, the data sets available for us actually tell a very different story. So if a prediction has to happen, that prediction has to happen on something which is available, which is verifiable. That is possible in a contemporary data sheet, a contemporary data set. What do you do about a data set which is compiled over a period of time, which had huge potential of error? What do you do about that? Now, I'm not just talking about figures. I'm therefore this example of human memory that I gave, which is constituted of a complex variable. What we are today is not because of X, Y, Z. What we are here today is because from A to Z, actually. That's where I stop.
So basically, that is why now this research has to start working on it, because data is available everywhere now. Now, so many data, like, see, now we have cameras throughout the road. We have so many data lying in the stations where, like, in the head office of this, like in the regulatory control office of these cameras, but we are not utilizing it. So that is why we should sit together, the people who have knowledge about this and the computer science engineers should sit together and do the research so that it can be utilized properly. So of course there are errors, so there are validity tests which is coming up, and then after the validation only it will come. Like Professor Babatosh Chanda told today in the morning that when there is when things becomes when things goes out of control, then definitely a balance will be coming. So similarly, so that is why the requirement of research is required now. Like even even the textbook which we are having, it actually, why we are believing in it, because it has gone evolution and it has gone through many years, and that is why we are doing it. So this is basically starting of AI now. So we should do research and we should work together so that it can be believable. This is in my opinion.
Generative AI is based on the based on the data, actual data, and if we are not able to access that data, how will AI will work for the social sciences?
Accessing the data,
It's not possible to access the data.
which data you are talking about? Access is not there.
In social problems, so many times you see the data is not accurate or not accessible. In that case, how will
So that you may have to, like, the data, where data is available, you should be knowing, and then proper permissions are to be taken, and then we will get data. Lot of data is available. Like in our museum, there are a lot of data about art forms. Everything is there, but we may not be able to access it directly. But we may have to go through a process so that we will get that.
But for social problems, some events are like that. We can't access, we can't get the accurate, because your predictions will be based on the accuracy of the data. If we are not able to get it, how will it?
That is what
it is going to help.
See, that is what is computer science people are looking into. The data should be trustworthy in the sense that all type of data should be there.
I'll have to ask for this to be continued over tea, because we also have a question from Alka, and I think that's going to be the last one that we can take. Yeah. Oh, sorry. Okay, that's the Dheeraj. Brief.
Thank you so much, Professor Lawrence. As this was the very interesting session, and many of you talk about the benefits of AI, but as Professor Bhatnagar and Professor Lawrence talk about the challenges of the artificial intelligence. So my question or my concerns is also related to the downside of the AI, because to use the AI we need certain skills. And in universities, many universities like using the AI chatbot as a reference assistance in abroad. I'm not sure about the IITs have started or not, but many universities are using. So my question is, how can universities leverage AI technologies to bridge the digital divide and ensure equal access to education and resources to all? So anyone can.
Yeah. Can I take Dheeraj's as well, and then we can ask people?
Thanks, Lawrence. Professor Bhatnagar, this is a question for you. Do we have instances within the AI world where, for instance, AI being prepared in the US or Western Europe, being developed in China or India, three different cultural geographies, and their cultural cultural preferences, biases, and positioning would, on certain matters that you talked about, race for that matter, would vary. So do we have scenario where AI being developed in a different cultural setup would have varied understanding of the cultural codes, or can it be possible that AI would have culturally a specific understanding of the cultural codes originating from different cultural setup, different nationalities? That's a if that's a possible, that means then we will be moving towards a more complex challenge. It won't be a universal or singular binary on black and white, male and female, but rather plurality, and within each plurality there would be binaries, and then there will be competition on that. Lawrence, you concluded your presentation with I would in the recent time I can remember that exhilarating and terrifying together. That's how it's so basically it draws from every crisis has also opportunity. So the crisis and opportunity may coexist, and here exhilaration and terrifying possibility may be knocking the door together. Now, if for the routine purposes in the justice system, we do have fast track courts. We are so much after setting up fast track courts to reduce the burden of cases. And I assume that fast track courts are not where the uniqueness and particularity of the justice is being sought for. Rather, it is generalization and routinization of the justice being delivered. So, can you apply the same observation to this demand for fast track courts and reducing the burden of cases on the judicial system?
So the first question on, I think. Yeah. So on digital divide, so I feel the use of AI in education can fill the gap. So by making the internet available, it is possible to record the performance of the student and automatic evaluation of the performance can suggest to the students that these are the areas that you need to focus. Or I don't know if that answers your question.
See, you were talking about some AI which is developed in other countries and we will be able to follow it or not. For example, autonomous driving. Autonomous driving scenario in America, Japan, or Europe is different from India. So we have to make, in India, if you want to do it, in India, in a road, we have some animals, all the type of vehicles, starting from two-wheeler to trucks, all are together moving on. So we won't be able to utilize the same scenario here. But here we have to develop further. So this is it. We will not be able to, of course, Professor Shantanu Chaudhary also talked about grounding. Red color can be identified, but it is related to the platform where it is we are looking for. So that is to be considered by the AI engineers. Then only it is possible.
We'll have to bring this session to a close. The problem with social scientists is you ask them to ask a question and you say 4, they ask 40. We all have chai to drink, So I'll end with thanking everyone on the panel for this great session and hand it back to Nidhi.
Thank you. Okay, so I'm going to just keep it very short because, as Lauren said, we not only have to have tea, but we want hot tea. So thank you so much, our esteemed panelists, and our gratitude to you. May I request our registrar, Dr. Nitin Malik, to kindly felicitate our esteemed panelists. Can I request the student volunteers? Yes. 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 To Professor Vasudha Bhatnagar. To Professor S. Indu. So special thanks to Professor Indu because it is through her that we were able to reach all our speakers of the first session. To Professor Ruchika Malhotra. That's the interesting part about our registrar. He knows most of us through our student days, as long as he doesn't spill the beans. Okay. Dr. Dvipobhoti Brahma. Okay, no, that's first Professor Lawrence.
Garka Murgi last.
No, Ghar ka Murgi is much better than dal, so no, not at all.
Yes, sir. One more, sir. Thank you, sir.
And Dr. Dvipobhoti Brahma. Can I also now invite Dr. Nitin Malik to propose a formal vote of thanks?
The intelligence says to propose the vote of thanks, and artificial intelligence says the tea is ready. I think that is what the message which Professor Lawrence was giving, that we can't have the tea until unless there is at least 4 questions. At least. So now we are back to our end of this day-long workshop on harnessing artificial intelligence for social sciences and humanities. And it had been a great idea and vision of our Honorable Vice Chancellor, Professor Singh Lather, because specifically
that this university, Dr. B.R. Ambedkar University, Delhi, has a focus on the social science, humanities, and liberal studies. So, when we are totally having a focus in higher education on social science, humanities, and liberal studies, so at least we should not be left behind and we should not be taken away from the development of the technology and specifically the artificial intelligence, which is the talk of the day today. So that is how it was emphasized by the Honorable Vice Chancellor, and we constituted a team that today we could see the first aspect, the first workshop which took place with such eminent speakers and lot of discussions, deliberation, starting from the artificial intelligence to the ethics of the AI to the other aspects which Professor Vasudha Bhatnagar and Professor Lawrence also talked about. And this is how we are here today at the end of this long workshop, pre-lunch session, post-lunch session, and now we are going to have a tea, which is the mandate by Professor Lawrence again and again. So not coming more into between, I'll just say one word, one line, because I am not a man from the computer science, I am not a man from the any other aspects of technology, but I am an anthropologist. And as an anthropologist, when I saw, I was too happy to see in the morning session that when the speaker in the morning, he stressed that intelligence and artificial intelligence specifically started from two thoughts, philosophy as well as sociology, and then came the part of the anthropology. So I was very excited to see that anthropology, sociology, and social sciences specifically, all aspects of social sciences, that is the base for even carving the artificial intelligence which the technologists and the technocrats are talking about today into our society and into the welfare of the human society. I am not coming into the aspects of the boon or bane. I am coming into whatever the artificial intelligence is contributing towards the human welfare. So it is a powerful force reshaping how we educate and empower the next generation. That is what we have been listening out since morning, starting from the speakers. And I thank all the esteemed speakers who came from far off and gave a good deliberation on the artificial intelligence, specifically relating it to the social science. I would like to thank Professor Shantanu Chaudhary, Director IIT Jodhpur, Professor Chanda, ISI Kolkata, Professor Ashok Chaudhary from ILBS, Dr. Brahma from IIT Jodhpur, Professor Ruchika from DTU, Professor Lawrence from our own university, Professor Indu, DTU, and Professor Vasudha Bhatnagar from Delhi University. The thanks also goes to the committee which has worked day and night to make this workshop a success, what we witness is today. And on that, the name goes to Professor C.S. Rai, Professor GGS IPU, Professor S. Indu. She's on the dais and she's one of the core committee members of our this endeavor. I am not taking one name I am missing. I'll speak about him in the last. Professor Ruchika Malhotra, Dr. Jyotirmay Bhattacharya, Dr. Dinesh Taneja, Director IT, Dr. Anshu Gupta, Dr. Nidhi, Dr. Shekhar Tokas, Dr. Akriti Grover, and Shri Sudhir Verma from the administration side. One man who really made all the people work together under the dynamic leadership of our Honorable Vice Chancellor is our Dean Planning, Professor Karthik Dave. And I would request everybody to give a big applause to him because it was his contribution, making all working into unison to make a workshop a grand success. Even till yesterday night, late night, he was messaging that this person has come, this speaker has come, we need to carry out this. And that is how the result comes when we work together as a team. So thank you, Professor Karthik Dave, for making this workshop a big success. Thanks also goes to all the PhD scholars who are here since morning, because that is what is very much required, that they know where the research is leading, where the research is going, and what they have to encounter or make into their future journey. Thanks is also to all the directors, deans, and all the faculty members who have been here throughout the day, making us more into a dialogue of how the artificial intelligence can be for the social scientists. And finally, I would like to thank these young volunteers from our BBA course, BBA program, the student of the BBA who have been carrying out this workshop preparation since last 2-3 days, and they were here in the venue right in the morning, and I think they were the first one to come over here, so energetic and enthused that they came over here and made the workshop a success. Thanks to you people also. The final thanks goes to the staff of the India Habitat Center, because they are going to serve us a tea now. We really need a tea. We had a good lunch and now a tea after the session. Once again, thanks to all the speakers, all the participants, and all who contributed to this workshop. Thank you very much. Kartik sir को भी बुलाओ। सर with you.